Hello, curious minds, and welcome to Documentary for Sleep. If you've ever wondered why our eyes seem both fragile and extraordinary at the same time, you're in the right place. Maybe you're lying in bed, letting this play while you drift towards sleep, or maybe you've got headphones on while working late into the night. This space is for slowing down and looking closer. Tonight, we're not diving into fantasy, but into evolution, into the deep history of our own vision. Human eyes might look weak compared to the sharp sight of an eagle or the night vision of a cat, but evolution rarely leaves things without reason. What seems like a flaw may hide a very different kind of strength. We don't have all the answers, but we do have the fossils, the comparisons, and the questions that guide us. And if you happen to drift off somewhere in the middle, that's perfectly fine. I've left full timestamps in the description so you can pick up where you left off tomorrow, because the whole arc of this story is worth following. If you enjoy this kind of calm, long-form storytelling, the kind that makes science soft and human, consider liking this video and subscribing. It helps this channel reach more curious sapiens like you. And I'd love to hear in the comments, where do you listen from, and in what moments? Are you in bed, on a night shift, or somewhere in between? And as always, stay curious, stay calm. In a quiet forest, among a troop of our closest primate relatives, you might notice a subtle but profound difference. Their eyes are often shrouded, the sclera, what we call the white of the eye, blending into a camouflage of darker skin and iris. But our own eyes stand apart. They are openly framed by a bright, expansive white canvas, a stark contrast that seems to serve no immediate purpose. It doesn't sharpen our vision for the hunt, nor does it help us hide from a predator's gaze. So why would evolution, that pragmatic sculptor, preserve such a seemingly extravagant and vulnerable detail? This question unfolds against a backdrop of meticulous scientific comparison. Studies of over 220 primate species reveal a singular truth. The human eye is an outlier. We alone possess this wide, luminous sclera, a brilliant frame that makes the colored iris a clear and unmistakable beacon. For a creature that once lived as prey, this is a curious design. It broadcasts the direction of our gaze to any animal or any person who cares to look. In the wild, such a trait should be a liability, a flashing signal to every threat in the vicinity. And yet, here we are. Evolutionary biologists see not a flaw, but a sophisticated adaptation. They call it a unique feature of our ocular morphology, and they argue its power lies not in solitary survival, but in social connection. The white of the eye is a collaborative tool, a silent communication device, far more potent than any sharpened claw. It allows us to discern the precise focus of another's attention from meters away, even if their head remains perfectly still. We can follow a companion's glance to a ripe fruit hanging high in a tree, to a predator stalking at the edge of the tall grass, or to a rival's subtle gesture. We can read a universe of intention in a simple shift of the eyes, a shared secret, a silent warning, a flicker of fear. Our survival came to depend less on individual might and more on collective intelligence, and our eyes evolved to fuel that exchange. Consider the eyes of other masters of survival. A cat's vertical pupils are exquisite instruments for ambush in the dim light of dawn. An eagle's piercing amber iris enhances its incredible long-distance acuity, a necessity for a hunter soaring above the earth. Theirs are eyes perfected for seeing. The human eye, in its deepest evolutionary purpose, seems to have been perfected for being seen. It is less a window looking out, and more a beacon looking to connect. The white sclera is less a biological structure and more a pointing finger, an emotional compass that guides our tribe through the complex social landscapes we built together. So perhaps our eyes did not evolve to become sharper, but to become more naked. They surrendered the safety of concealment for the profound power of shared attention. They became instruments of empathy, allowing trust to build and culture to flourish through a mere glance. But this choice, like all evolutionary bargains, came with a cost. For if our eyes are so exquisitely tuned for connection, what are we to make of the inherent flaws hidden within their very architecture? What happens when the instrument of connection itself contains a void, a blind spot where nothing can be seen at all? Each of us carries a hidden void within our own gaze, a silent and permanent gap in our vision we are blissfully unaware of until it is pointed out. It is a blank spot on the canvas of our sight, a place where the world simply ceases to be. Yet we never see the emptiness. This is the blind spot. And once you know it is there, you cannot not know. The mind, once made aware of its own flaw, is forever changed. The story of this blind spot begins not with an error, but with a compromise. At the back of our eyes lies the retina, a delicate tapestry woven with millions of light-catching cells. But this tapestry must send its captured story to the brain. The optic nerve, that thick bundle of fibers, is the messenger. And in our eyes, this messenger chose the most direct path. It barges straight through the intricate weave of the retina, gathering all the threads of visual information, and exits out the other side to begin its journey to the brain. The hole it punches through is the blind spot, a place where there are no light-sensitive cells, only the nerve's point of departure. It is a biological fact, a universal human trait, as common as breath, yet as personal as a secret. Evolution, however, is not a single-minded engineer striving for perfection. It is a tinkerer, making do with available materials. This particular design, it turns out, is not the only way. Look to the squid, a creature of ancient lineage, or the peculiar platypus. Their eyes were built on a different blueprint. In their design, the photoreceptor cells face the light directly, and the neural wiring runs behind them, collecting the data without ever disrupting the canvas. Their optic nerve exits gracefully from the rear, leaving the retinal surface pristine and unbroken. They see without a void. One might call it a more elegant solution, a cleverer bit of biological engineering. So why did we end up with the flawed design? Perhaps it was a trade-off. Perhaps the benefits of our particular retinal structure, its high resolution in the center, its sensitivity to color and detail, outweighed the cost of this one small blind spot. Evolution often chooses the path of good enough over perfect, especially when good enough allows for survival and reproduction. The blind spot, then, is not a mistake, but a relic of a choice made deep in our ancestral past, a signature of a different set of pressures and priorities. It is a scar from a battle we don't remember fighting, a whisper of the countless forks in the road that led to us. But here, the story shifts from the architecture of the eye to the magic of the mind. For we do not walk through the world constantly bumping into things we cannot see. Our brain, that masterful illusionist, refuses to accept this nothingness. It takes the information surrounding the void, the colors, the textures, the lines, and seamlessly paints in the gap. It extrapolates, it guesses, it creates a continuous picture. We do not see the
world as it is. We see a sophisticated reconstruction of it, a best-guess narrative composed by a silent storyteller in the dark of our skull. Our vision is not a direct feed, but an act of profound and constant interpretation. This raises an unsettling, almost philosophical vertigo. If such a fundamental part of our perception is a carefully crafted fabrication, how much of what we see is truly there? Is our vision, for all its wonder, inherently weaker, more illusory than that of the squid, who may see a world less rich in detail, but perhaps more honest in its raw presentation? Or is the brain's ability to weave a coherent whole from fragmented data the true marvel, making our sight not weaker, but profoundly different? We pride ourselves on observing the world, yet we are blind to the very mechanisms that create it for us. If a simple blind spot can reveal such a deep truth about the constructed nature of our reality, what other unseen voids are we constantly, gracefully, walking over without ever knowing they are there? And if we are only seeing a story told by our own minds, what chapters are we missing entirely? The world around us is a riot of color, a brilliant tapestry woven from the light of the sun. We navigate our lives by this visual symphony, believing we see the world as it truly is. But this is an illusion, a beautiful and necessary deception. In truth, Our eyes are merely sampling a whisper-thin slice of an immense and roaring spectrum. We live our entire lives inside a small, well-lit aquarium, mistaking its glass walls for the boundaries of the entire ocean. This narrow window through which we peer at reality is known as the visible spectrum, a band of light stretching from about 380 to 740 nanometers. It is our entire visual universe. Yet, just beyond the violet edge of our perception, ultraviolet light dances, a secret world seen clearly by bees who use its invisible patterns to navigate to the heart of a flower. Beyond the red, infrared radiation pulses with the heat of life itself, a landscape read effortlessly by a rattlesnake sensing the warm-blooded promise of its next meal. To them, we must seem nearly blind, oblivious to the rich layers of information painting the air and the earth. This biological constraint is not a flaw, but a specific evolutionary choice, written in the language of our cells. Our vision is built upon the work of 3 types of cone cells, each tuned to a specific range of that narrow band: red, green, blue. Like a painter with only 3 primary colors, we mix and match to create the millions of hues we know. But consider the mantis shrimp, a creature that seems to have fallen from a science fiction novel. It possesses not 3, but up to 16 different types of photoreceptor cells. It perceives polarized light and a spectrum of colors we cannot name and could never imagine. Its reality is built from a palette of unimaginable richness. What does its world look like? It is a question we can ask, but one we can fundamentally never answer. This limitation extends far beyond mere imagery. It shapes the very fabric of our perception and consciousness. Our art, our fashion, our very definition of beauty is curated within this tiny sliver of possibility. The melancholy of a gray day, or the quiet joy of a golden hour sunset, are emotional responses triggered by wavelengths of light we can process. We even have a name for the profound sadness that can descend when this light dwindles: seasonal affective disorder, proof that our biology is tethered to the sun's filtered gifts. Our entire aesthetic and emotional experience is, therefore, a local phenomenon, a unique product of our specific sensory niche. This inherent partiality forces a deeper question. Was this sensory deficit the very catalyst that propelled us toward other forms of seeing? Did our inability to perceive the full physical grandeur of the world force us to invent imagination, to develop symbolism and language to describe the unseen? Our myths and metaphors are filled with attempts to grasp the invisible, from divine auras and spiritual planes to the dark matter and cosmic radiation of modern physics. Perhaps our greatest tool is not vision, but the mind's eye that looks beyond it. We built instruments to extend our senses, translating ultraviolet and infrared into colors we can understand, creating a prosthetic vision to peek outside our aquarium. But does this make us masters of perception, or merely its most ingenious prisoners? We can describe the physics of a rainbow to a mantis shrimp, but we cannot let it see what we see. Likewise, it could never explain its world to us. We are all confined to the truth of our own biology. So if our most trusted sense reveals only a fraction of what is real, what else are we missing? What truths echo just outside the range of our perception, forever silent to our ears and invisible to our eyes? This realization humbles, but it also invites a thrilling curiosity. If our own vision is so relative, so particular to our species, then who truly sees the world more clearly? Does the eagle, soaring high with eyes sharp enough to spot a rabbit from a mile away, possess a superior reality? Does the cat, whose world bleeds into the shadows of the night, see a truth we sleep through? Or does the squid, communicating with complex patterns flashing across its skin in the ocean's dark, hold a deeper understanding of light itself? You think you have good eyes? Consider this. From a height that would reduce a mountain to a map, an eagle can discern the twitch of a rabbit's ear in the grass far below. In the deep indigo of a moonless night, a house cat navigates a cluttered room with silent, liquid grace, its world painted in shades of light we cannot perceive. And in the shifting, dappled gloom of the ocean, a squid's eye does not merely see shape and movement. It reads the very polarization of light, a hidden dimension of vision entirely closed to our experience. Our own sight, the very lens through which we apprehend the entirety of our reality, is but a single narrow window in a mansion of perception. The question, then, is not who sees best, but how each way of seeing constructs an entirely different version of the world. The architecture of an eye is a story written over millions of years, a biological testament to survival. It is not a blueprint for perfection, but a collection of exquisite compromises. Each design is an answer to a specific set of questions posed by an environment. The compound eye of an insect offers a panoramic, flickering view of the world, excellent for detecting the slightest motion, a crucial advantage when a shadow could mean a predator. The elliptical pupil of a cat, a vertical slit that can open to a full moon or narrow to a hairline crack, maximizes light intake and depth perception for the pounce. The cephalopod's eye, which evolved along a path startlingly similar to our own, yet diverged in a key way, can filter and interpret polarized light, turning the ocean's chaotic glare into a canvas of contrast and communication, a secret language written in light waves. Even the seemingly limited color vision of a dog, a world painted in yellows and blues, is perfectly tuned to detect the movement of prey against a backdrop of foliage. Every eye is a key, and it only fits the lock of its own ecological niche. Our human vision, then, is our own unique key. It did not evolve for the long-distance reconnaissance of the eagle or the nocturnal ambush of the cat. It was forged in the fires of social living. Our eyes prioritize color discrimination and sharp central detail. We possess 3 types of color-sensitive cone cells, a trichromatic view, that allow us to distinguish between millions of color shades. This is not merely for appreciating a sunset. It was, and is, vital for reading subtle signals. The blush on a cheek, the pallor of illness, the ripening of fruit against a green canopy, these were the visual cues that mattered. Most critically, the high acuity in the very center of our retina, the fovea, gives us a powerful ability to read the most complex and informative object in our social world, the human face. We are exquisitely attuned to the minute contractions of muscles around the eyes and mouth, able to parse a micro-expression of fear, a flicker of disgust, or a genuine Duchenne smile from a false one. Our eyes are not just optical instruments. They are empathic portals, designed for connection and understanding. When placed side by side with the champions of the animal kingdom, our visual hardware seems almost mediocre. In a test of raw resolution, we are humbled by the eagle. Its retina boasts a density of cone cells up to 5 times greater than our own. Where we might see a blur of green, the eagle sees individual leaves. Its world is rendered in ultra-high definition, a necessary clarity for spotting a potential meal from a cruising altitude of 3 kilometers. It sees a broader spectrum of colors, including ultraviolet light, revealing patterns on flowers and prey that are entirely invisible to us. In a contest of light, we are defeated by the cat. Its eyes possess a reflective layer behind the retina, the tapetum lucidum, which acts like a mirror, bouncing photons back through the photoreceptor cells for a second chance at capture. This is why a cat's eyes glow in the dark, and why it needs only 1/6 of the light we require to see. And in the realm of light's properties, the squid and its cephalopod kin perceive a dimension we cannot. Their ability to detect polarized light cuts through the ocean's haze and glare, turning the water into a medium for high-contrast signaling, a private channel for communication and hunting in an environment where color is quickly filtered out. By these purely biological metrics, we are the losers. We are far-sighted apes who cannot see in the dark, our visual acuity paling against the raptors, our light-gathering ability laughable to the feline. Yet, to declare a winner based on these criteria is to miss the point entirely, for the human eye did not evolve in isolation. It evolved in tandem with the most powerful social brain on the planet. Our vision is not merely about capturing photons, it is about interpreting intention. We don't just see a pair of eyes, we read them. We see a narrowing of the pupils and infer concentration or suspicion. We catch a fleeting glance and understand a shared secret. We witness a steady gaze and perceive a challenge or an offer of trust. This ability to read the mind in the eyes is the true superpower of human sight. It is the foundation of empathy, complex cooperation, and culture. It allowed our ancestors to coordinate a hunt not just with grunts and gestures, but with a shared look of understanding. It is the bedrock of the social contracts that bind us together. So the human eye, while clearly not the most powerful biological instrument, may well be the most sophisticated social one. It served the ultimate human weapon, which was not claw nor fang, nor unparalleled speed, but our profound ability to understand one another, to build shared purpose, and to weave the intricate web of society. Our sight is the primary input for this system. It is a tool for building a shared reality, a common ground of understanding that allows dozens, then hundreds, then millions of individuals to act as one. The eagle sees the rabbit, but can it see the trust in its partner's eye as they coordinate a dive? The cat sees the mouse in the dark, but can it see the unspoken grief in its companion's posture? Our vision is the gateway to our humanity, and yet, this trade-off left us with a curious vulnerability. Our nights are illuminated by artificial suns because we are blind in the very darkness where other creatures reign. If our vision is so perfectly honed for social survival, why did our ancestors not push further into the nocturnal realm? Why did we not evolve to become the ultimate predators of the night, adding that fearsome advantage to our growing repertoire? What greater fear kept us huddled in the fading light, preferring the vulnerability of darkness to the prizes it might hold? Turn off the lights, and the world you know dissolves. The solid edges of the table, the familiar path to the door, the reassuring features of a loved one's face, all melt into a formless, impenetrable gloom. In this sudden blindness, we are humbled. We are reminded of our place. We are not the masters of this domain. A house cat's eyes will gleam with an alien light, capturing the faintest photons to navigate the room with silent grace. An owl on the hunt can strike a mouse by the sound of a rustle in total blackness. But us? We fumble. We hesitate. We reach out with nervous hands. We are creatures of the day, seemingly abandoned by evolution when the sun goes down. Why would our ancestors, in their brutal struggle for survival, leave us so vulnerable? Why did we not become the ultimate predators of the night? To understand this apparent flaw, we must step back into the deep, sun-drenched time of our early ancestors. Picture not a shadowy forest of lurking terrors, but the vast open savannas of Africa, washed in brilliant, unforgiving light. Here, Homo erectus walked upright, and later, Homo sapiens began their journey. Their world was not defined by the cloak of night, but by the clarity of day. Their survival did not hinge on ambushing prey in the dark, but on a different set of skills, recognizing the subtle blush of ripe fruit against a canopy of green, spotting the distant, shimmering silhouette of a herd of antelope on the horizon, and most importantly, reading the intricate, fleeting expressions on each other's faces. Their life was a visual symphony played under the bright sun, and their eyes evolved to be perfect instruments for that specific concert. The secret to night vision lies deep within the retina, a thin layer of tissue at the back of the eye. Here, two types of photoreceptor cells, rods and cones, wait to capture light. Rods are the specialists of the dim. They are exquisitely sensitive, able to fire off a signal from the strike of a single photon. They are the reason a cat can see in light levels 6 times lower than what we need, but they see only in shades of gray, offering a blurry, low-resolution picture of the world. Cones, on the other hand, are the cells of the day. They demand more light to operate, but they grant the gift of color and sharp, high-resolution vision. The human eye is a study in this trade-off. We possess a much higher density of cones, particularly crammed into a small area called the fovea, which gives us our pin-sharp central focus. Our rod cells, while present, are outnumbered and outmatched by those of a true nocturnal hunter. We sacrificed sensitivity for stunning clarity. Furthermore, the story does not end in the eye itself. It continues along the neural pathways that lead to the brain. The information captured by our retina is sent for processing to the visual cortex, a powerful computational center that has become exceptionally adept at interpreting complex scenes in good light. It excels at edge detection, pattern recognition, and color differentiation, skills paramount for identifying a predator disguised in the grass, a tool-shaped stone among thousands, or a frown of disapproval from a tribesmate. This brainpower is our true visual advantage, but it is a processor that requires high-quality data. It is a brilliant strategist that goes idle when its intelligence, the stream of detailed visual information, is cut off. In the dark, it is left with nothing but the faint, grainy whispers provided by our few rods, and it cannot weave them into a coherent picture. We are not just blind in the dark. Our most powerful visual asset is rendered useless. Confronted with this limitation, our ancestors faced an evolutionary choice: the path of the body or the path of the mind. One option was to continue the slow biological arms race, to develop larger eyes, more rods, a reflective layer behind the retina, the tapetum lucidum that makes animal eyes glow to bounce light back through the photoreceptors for a second chance. This was the path of the owl, the cat, the tarsier. It is a magnificent adaptation, but it is also a specialization. It locks a species into a particular niche. Our ancestors chose the other path. Instead of evolving better night vision in our bodies, we began to create it outside our bodies. We mastered fire. The leap from fearing wildfire to cultivating it was a cognitive revolution. A controlled flame was more than warmth and protection. It was the first sunrise humanity could schedule. It pushed back the night, creating a bubble of light and safety where social bonds could be strengthened, tools could be fashioned, and stories could be told. This was our evolutionary workaround. We didn't need to see in the dark because we learned to banish the dark. The torch, the lamp, and eventually the electric light bulb are not merely conveniences. They are the extensions of our visual apparatus, the exoskeleton of our sight. We outsourced the problem. This choice set us on a fundamentally different trajectory. It favored the clever, the innovative, the social cooperator who could tend the fire and share its light. It privileged the brain that could imagine a solution beyond the limits of its own biology. Our weakness became the catalyst for our greatest strength. The night that blinded us forced us to become inventors. Yet every adaptation carries its own hidden cost, a secondary vulnerability. Our dependence on external light has woven a deep fallibility into our design. To achieve such stunning visual acuity for the day, to become masters of communication and detail, we built an optical instrument of incredible precision, but also of immense fragility. Our eyes, the very windows to our bright world, are exposed and delicate. They can be blinded by a flash of light, scarred by a grain of sand, clouded by the slow creep of time. This vulnerability whispers of a different priority in their design. Perhaps they were not forged solely for the ruthless calculus of survival, to spot the predator a moment sooner. Perhaps they were also refined for the softer, yet equally powerful demands of connection. To hold a gaze, to convey a thought without words, to share a moment of wonder at a sunset. If our eyes are so fragile, so easily lost, is it because they were designed not just to see the world, but to be read by another? Is the human eye, ultimately, a tool for conversation as much as it is for capture? And if that is true, what does it mean that we now spend our lives staring into the cold, unblinking light of screens, a world that sees us but cannot truly look back? A stray eyelash, a mote of dust, a gust of dry wind, each is enough to make us wince, to send our hands flying to our faces in a frantic, instinctive blink. The eye, that celebrated window to the soul, is also its most vulnerable gateway. It is a paradox of exquisite design, an orb of delicate jelly and finely tuned nerve, left astonishingly exposed to the world's harshness. One must wonder, if evolution is the great engineer of survival, why did it not better armor this, our most precious sense? Why leave such a critical instrument so perilously open to injury? The answer, perhaps, lies not in the logic of the solitary predator, but in the quiet calculus of the social creature. Compare the human eye to those found elsewhere in the animal kingdom. A bird diving into a river for fish possesses a nictitating membrane, a transparent third eyelid that sweeps across like a wiper blade, offering protection without sacrificing vision. A crocodile lurking just below the water's surface uses a similar shield, its gaze unblinking and ancient. Even our primate cousins like the gorilla have eyes set deeper within a bony, brow-ridged fortress, a design that speaks of brute force and defense. Our own eyes, by contrast, seem almost naively presented. They are forward-facing, prominent, and framed by skin so thin the blue maps of veins show through. They are not hidden away but displayed, a pair of gleaming orbs offering a constant, unguarded broadcast. This exposure is no evolutionary oversight. Researchers in evolutionary neuroscience propose a compelling theory. The human eye was pushed forward, made vulnerable, not for seeing better in the physical sense, but for communicating better in the social one. Our entire facial architecture is a canvas for emotion, and the eyes are its most vivid paint. They are the focal point. The subtle squint of skepticism, the wide-eyed flash of surprise, the crinkling at the corners that signals genuine joy. These micro-expressions are the unspoken language of our species. A thick, opaque eyelid, or a permanent protective membrane would be like placing a veil over the mouth. It would stifle the conversation before it could even begin. The pupil itself, that black aperture to the soul, is a betrayer of our inner state, dilating not just to light, but to interest, to attraction, to fear. Could such a nuanced signal be transmitted through a hardened lens? It seems unlikely. Our eyes were optimized for connection, not just for collection. This trade-off becomes starkly clear when we examine the mundane, constant maintenance our eyes require. The crocodile, with its built-in goggles, need never blink. We, however, must perform this moistening, cleansing ritual countless times a day, a rhythmic interruption to our vision that we accept without question. Each blink is a moment of self-imposed blindness, a tiny sacrifice we make to keep the windows clear. It is a fragile system. We produce tears not only to wash away irritants, but to express profound grief or overwhelming happiness. The very fluid that keeps the mechanism functional is also the medium of our most powerful emotional outpourings. In this way, the eye is forever straddling two worlds, the biological and the emotional. It is an organ that must see the world, yet cannot help but show the world what we feel inside. So, is this profound vulnerability a design flaw? Or is it, instead, a deliberate and magnificent sacrifice? Perhaps the question itself is framed incorrectly. The weakness is the strength. The very fact that a speck of dust can disable us forces us into a community of care. A child squinting in the sand will immediately seek help from a parent. An adult with something in their eye will instinctively turn to a stranger. This vulnerability fosters interaction, a moment of shared humanity. It is a biological trigger for social bonding. The eye's design whispers that our survival has always depended less on individual armor and more on collective understanding. Its exposure is an invitation, a promise of legible intention that allowed tribes to coordinate, lovers to connect, and societies to build trust. We traded a club for a cradle. And if the eye is indeed our primary tool for emotional broadcast, then what is its most powerful signal? What is the look that can convey more than 1,000 words, that can disarm anger, elicit compassion, or forge an instant bond? It is a language written in moisture and light, a silent testament to the idea that we evolved not just to see, but to be seen. And in being seen, truly seen, we find a reason to protect one another. For if the eyes are the windows to the soul, their fragility is what compels us to be each other's guardians. But if the eye is indeed a social instrument first, and a biological one second, what does that say about the very nature of our emotions? Are the tears that well up merely saline solution, or are they the visible proof of a feeling too immense to be contained? When someone's eyes well up with tears, You can feel your own heart clench in response, even before a single word is spoken. It's a silent transmission, a surge of shared feeling that bypasses language entirely. How did the human eye, a biological instrument designed to capture photons, evolve into such a potent emotional broadcast system, a medium that speaks directly to the soul? The answer lies not in the eye's hardware, but in the unique software of human sociality. Over millennia, as our ancestors began to collaborate, to build communities, and to navigate the intricate webs of social bonds, survival came to depend on more than just strength or speed. It hinged on connection, on empathy, on the ability to silently signal intention and understand the inner state of another. In this evolutionary theater, the human eye underwent a subtle but revolutionary adaptation. We developed a strikingly large sclera, the white of the eye, a canvas that makes every minute movement of our iris and pupil starkly visible. Unlike most primates whose dark sclera camouflage their gaze, making it a private secret, our eyes are an open book. This was not a biological flaw, but a social leap. Our gaze became a tool for communication, a window we deliberately left open for others to peer into. The eye transformed from a mere organ of sight into a sophisticated instrument of social and emotional intelligence, a beacon broadcasting our fears, our joys, our curiosities, and our trust. Neuroscience offers a glimpse into the machinery behind this silent conversation. Functional MRI scans reveal that when we meet another's gaze, a rapid-fire circuit in our brain ignites. Specialized neural networks, including the fusiform gyrus dedicated to facial recognition and the superior temporal sulcus, which tracks where others are looking, activate in concert. This entire process can unfold in less than 200 milliseconds, faster than a conscious thought. We are wired to read eyes. We instinctively follow another's glance to see what has captured their attention, a phenomenon known as joint attention that forms the bedrock of learning and collaboration. We unconsciously note the subtle dilation of a pupil, a sign of interest, attraction, or even fear, and our own body chemistry responds in kind. This is not a learned politeness. It is a deep, hardwired language. The ability to read the story told in a slight squint, a brief widening, a flicker of moisture, is a hallmark that profoundly separates human social behavior from that of our closest primate relatives. It is the foundation upon which we build empathy. Consider the contrast. If a dog stops chewing your shoe the moment you lock eyes with it, this is likely a learned behavior, a response to your past reactions. It understands the gaze as a command, a signal of dominance. But when a human looks into the eyes of another human shimmering with grief, something else entirely occurs. They don't just see sadness, they feel it. A mirroring takes place. The observer's brain may simulate a shadow of that pain, a faint echo of the neural patterns firing in the other person. This is more than vision. It is visceral sensation. We don't just observe a tear tracing a path down a cheek. We feel the salt of it on our own skin, the weight of the burden that caused it. The eye is the conduit for this profound emotional transfer, blurring the line between the self and the other. It is the bridge across which compassion travels. And yet this very bridge of connection can also be weaponized. Because we are so exquisitely tuned to believe what the eyes seem to tell us, they become the perfect instrument for deception. A practiced liar can wield a steady gaze to feign sincerity, masking the turmoil within. A predator can use a warm smile that reaches their eyes to lure trust, exploiting our deepest instincts for connection. The same white sclera that allows a mother to see the flicker of fear in her child's eyes also allows a charlatan to perfectly pantomime concern. Our greatest tool for building trust is also our greatest vulnerability. We are, in a sense, hardwired to be gullible, to believe the story the eyes appear to tell. So, if our most trusted emotional channel can be so expertly hijacked, where does that leave our faith in one another? Can we ever truly know if the window is clear or if we are merely admiring a cleverly painted pane of glass? The white sclera that made us masters of connection also made us susceptible to the most profound betrayals. If the eyes are the windows to the soul, What does it mean when we discover the glass is two-way, or that the view is a meticulously staged illusion? If the eyes are the windows to the soul, then anyone can look in. But what happens when the person on the other side of that window is lying, and you have no way of knowing? We often speak of a penetrating gaze, one that seems to see right through us, laying our secrets bare. But this very instrument of truth-seeking, the human eye, with its stark white canvas encircling a darker center, might also be our greatest vulnerability. It is a biological masterpiece of communication, unparalleled in the animal kingdom, yet it is a double-edged sword. The same feature that allows us to share a moment of silent understanding, to convey love or alarm with a single glance, also renders us exquisitely susceptible to deception. Our large, bright sclera, the white of the eye, acts like a high-contrast arrow, unmistakably signaling the direction of our attention. It is a tool for connection that can be weaponized for manipulation, turning a window into a carefully staged display. This unique ocular architecture did not evolve by accident. In the dense social forests of our ancestors, survival depended not just on reading the environment, but on reading each other. A flash of white in the periphery, a sudden shift in a companion's gaze. These were critical data points. They could signal a hidden predator in the branches above, a ripe fruit cluster just to the left, or a potential ally making a covert gesture. Our brains became hardwired to process this information with lightning speed, prioritizing it over other visual cues. This is the foundation of what scientists call gaze cueing, a subconscious and automatic process where our own attention is pulled, almost like a magnet, toward wherever someone else is looking. It is a silent, powerful form of social coordination, a neural dance that happens below the level of conscious thought. Our choices, our perceptions, even our memories, can be subtly biased by where we see others looking. In a very real sense, we are built to follow eyes. This deep-seated instinct is the very lever a skilled deceiver can pull. Research into the deceptive gaze reveals a fascinating paradox. While we might culturally believe that a liar avoids eye contact, proficient manipulators often do the exact opposite. They understand, intuitively or through practice, that a steady, sincere-seeming gaze is a currency of trust. They consciously use their eyes to project honesty, to hold our attention, and to sell a fiction. The bright, visible sclera makes this performance possible, granting them the precise tool to control the narrative of where they appear to be looking, and thus what they appear to be thinking. It allows for a masterful puppetry of social cues. The wider they open their eyes, the more they engage that primal part of our brain that screams, "Pay attention! This person is focused on you. They are being open." It is a biological hack, an exploitation of an ancient trust-building mechanism. The very feature that allows for profound empathy also enables profound deceit. We see this delicate dance play out everywhere in human society, a constant interplay of truth and theater directed by the eyes. A talented salesperson doesn't just show you a product. They guide your attention with their gaze, landing on a feature just as they mention its benefit, forging a subconscious link in your mind between their directed look and your perceived desire. Their success hinges on their ability to use this gaze cueing to build rapport and appear genuinely invested in your needs. Conversely, a charismatic politician on a debate stage might use a deliberate, calculated break in eye contact not at random, but at a crucial moment. They might glance away with a hint of weariness when an opponent's name is mentioned, or sweep their gaze across the crowd with a look of shared frustration, creating a silent, unspoken alliance against a common foe. They aren't just seeing, they are directing the sight of thousands, framing who is to be trusted and who is to be doubted. Vision feels like our most reliable sense, a direct pipeline to objective reality. But the story of the sclera suggests it is anything but neutral. Our sight is social, emotional, and deeply prone to influence. So, are our eyes not just a biological weakness, but a psychological one? Is this exquisite vulnerability the price we pay for our complex social bonds? To unravel this further, we must look back to the very beginning of human connection, to the very first conversations that happen not with words, but with looks. Why does an infant, fresh to the world, spend so much of its quiet alertness staring, utterly captivated, into the eyes of its mother? Is this a simple, hardwired reflex, a genetic program kicking in? Or is it the first, most crucial lesson it will ever learn? A newborn, still wrapped in the soft haze of a world they do not yet comprehend, cannot speak. They cannot smile. Their limbs move with the uncoordinated, jerky randomness of a marionette on strings not yet mastered. Yet, they can do one thing with a power that can stop a heart. They can stare into their mother's eyes. This gaze is not a blank look. It is an intense, profound, and deliberate act. It is a silent language written in the chemistry of connection, a primal dialogue that forges a bond deeper than words, a bridge built long before the first syllable is ever uttered. This is not a learned behavior, a trick picked up in the first few days in a bright new world. It is something far more ancient, etched into the very code of what makes us human. Research from institutions like University College London reveals a startling truth. Infants only days old can already distinguish a human face from the visual noise of their environment. And within that face, they are magnetically drawn to the eyes. It is the focal point of their nascent universe, the only feature they seek out with what appears to be clear, purposeful intent. This is the first, most fundamental interaction, a biological imperative executed with the quiet precision of a reflex. The world is a blur of shapes and light, but the eyes are a constant, a beacon in the fog. They are the anchor point for a consciousness just beginning to test its own existence. To understand the weight of this gaze, we must step back and view it not as a simple cute gesture, but as a critical evolutionary strategy. We are a species born profoundly vulnerable. Consider the newborn of other creatures. A wildebeest calf struggles to its feet within minutes of birth, its legs trembling but functional, its survival dependent on its ability to flee. A sea turtle hatchling scrambles instinctively toward the moonlit ocean, guided by an innate map it did not choose. Their tools are physical, their strengths immediate. A human infant possesses none of these defenses. We are born neurologically unfinished, our brains a landscape of immense potential waiting to be wired by experience. We cannot run. We cannot hide. Our survival does not depend on the strength of our limbs, but on the strength of our bonds. Our evolutionary cradle was not the open savanna alone, but the intricate, demanding social group within it. Our primary instinct, therefore, is not to flee, but to attach, to fasten ourselves to another, to ensure our care, our protection, our very lives. And the gaze is the ultimate tool of attachment. It is the fastest bridge between two nervous systems. When a mother and her newborn lock eyes, a powerful biological dance begins. In the mother, this sustained eye contact triggers a cascade of oxytocin, the neurochemical cornerstone of love, trust, and bonding. It softens her, focuses her, compels her to nurture. In the infant, this same interaction begins to lay the foundational wiring for social and emotional intelligence. They are not just seeing eyes, they are learning to read them. They are learning that this specific visual pattern is followed by comfort, by food, by warmth, by safety. They are learning the first lesson of human connection, that attention is met with care. This reciprocal loop, this silent conversation of looks and chemicals, is the bedrock upon which the entire complex structure of human society is built. It is our species' first and most vital language. We did not conquer the world with tooth and claw, but with this, with the ability to see and be seen, to understand and be understood on a level that transcends the physical. So, the infant stare is far more than a reflex. It is an invitation. It is a tiny hand reaching out from the isolation of a new consciousness, seeking the confirmation of another. It is the spark that ignites the fire of empathy, the first thread in the vast, intricate tapestry of a human life. But this act of looking is only the very beginning of the story. It is the first note in a grand symphony of neural coevolution. For the gaze to transform from a simple biological signal into a vessel of deep understanding, something remarkable had to happen. The tool and the craftsman had to evolve together in a delicate, million-year dance. The eye was not merely a camera passively recording data for a separate brain to process. The brain was not a solitary computer waiting for visual input. They shaped each other, refined each other, pushing one another toward greater and greater complexity. The need to see intention in a glance, to perceive sorrow or joy in a slight squint, to understand a shared truth in a mutual look, this need sculpted our neurology as much as our optics. What began as a survival mechanism looked to be loved, to be fed, to survive, slowly, over eons, became the foundation for our greatest gift, the capacity to feel with and for another. The hardware of vision and the software of cognition became so deeply intertwined that we can now look into the eyes of another and not just see an object, but glimpse a universe. We can see a story, a pain, a love, a soul. The simple primal stare of an infant contains the seed of all poetry, all art, all compassion. It is the origin point of every great human endeavor that requires us to see the world through another's eyes. But how precisely does this miracle occur? How did the raw act of looking evolve into the profound capacity for understanding? If the gaze is the first question, then how did the brain and the eye learn to write the answer together? What had to change, not just in the orbit of the eye, but in the very architecture of the mind, to turn light reflecting off a retina into the luminous, intangible force of empathy? We do not merely see others, we understand them through a gaze. It happens in an instant, a silent exchange that carries the weight of 1,000 words. But how does the brain, a 3-pound organ of cool gray matter, learn to decipher emotion through 2 small apertures in the face? How does it translate light into feeling, a glance into a shared understanding? This ability, so effortless and innate, is not a simple biological switch. It is the culmination of an evolutionary pas de deux, a slow dance between eye and brain that transformed sight into insight and observation into empathy. Over 2 million years ago, on the sun-scorched savannas of Africa, a pivotal shift began within the cranium of our early ancestors, Homo habilis. Their world was one of immediate physical threats and fleeting social opportunities. Survival depended not just on spotting a predator hidden in the grass, but on interpreting the subtle, silent signals of one's own kind. A slight widening of the eyes in a fellow hominin could signal approaching danger. A softening gaze might indicate shared curiosity or a willingness to cooperate. In this crucible of social necessity, the brain began to reshape itself. The occipital lobe, the command center for processing raw visual data, expanded its territories. But more importantly, neural pathways began to weave this data into a richer tapestry of understanding. The temporoparietal junction, a region that would later become crucial for social cognition, began to stir. It was here that the brain started its first, tentative experiments in distinguishing the intentional glance from the accidental look, the friendly gaze from the hostile stare. The eye was evolving from a mere tool for navigation, a biological camera, into a bridge between minds, a translator for the unspoken language of social life. This neural architecture, forged in the ancient past, is what we activate every time we lock eyes with another person today. The process is breathtaking in its speed and complexity. Light reflecting from another's iris enters our eye and is converted into electrical impulses. These signals race down the optic nerve to the occipital lobe, which assembles the basic image, the shape of the eyes, the direction of the gaze, the subtle contractions of the surrounding muscles. But this is only the beginning. This raw visual information is then fired along a superhighway of neural connections to other specialized regions. The amygdala, the seat of emotion, is alerted almost instantly, providing a gut-level emotional color to what we are seeing. Is this a threat? A comfort? Simultaneously, a remarkable set of cells known as mirror neurons begin to hum. Scattered across key brain regions, These neurons fire not only when we perform an action, but also when we witness someone else performing that same action. See a hand grasp a cup, and the neurons for grasping a cup fire in your own brain. Critically, this mirroring system extends to expressions. When we see a smile, the neural circuitry for smiling faintly activates within us. When we see eyes well with tears, the regions associated with our own sadness flicker to life. We are, in a very real physiological sense, experiencing an echo of the other person's inner state. This is not cold calculation. It is an embodied simulation. We don't just recognize happiness or sorrow on a face. We feel a whisper of it within ourselves. This entire symphony of perception, emotion, and simulation takes less than a second. It is the invisible engine of empathy, allowing us to step, if only for a moment, into another's shoes simply by looking into their windows. This profound human capacity stands in stark contrast to the way our most advanced machines quote see, unquote. A sophisticated I can analyze an image of a human face with incredible precision. It can map every contour, identify the exact angle of the eyebrows, and classify the expression into a category like joy or anger based on a vast data set. But it does not feel joy. It does not know anger. Its processing is a form of sophisticated pattern recognition, devoid of the internal emotional resonance that defines our experience. It sees the data, but it misses the meaning. For humans, this meaning is everything. It is the foundation upon which we build trust, cooperation, and moral communities. Our ability to feel what others feel, kindled by a shared gaze, is what compels us to offer a comforting hand, to share resources, to condemn cruelty. Yet this same system has a dual edge. Because we can intuit emotion, we can also learn to mimic it. We can weaponize a glance, feigning empathy to manipulate, using a calculated gaze to build false trust. The same neural bridge that connects us so deeply can also be used to deceive us. This suggests that empathy, born from the need for social cohesion, may have also been the birthplace of social cunning. If the eye and brain have been co-evolving for millennia to emotionalize information, to turn light into shared feeling, then what does this silent language of the body truly contain? What unspoken covenants are formed and broken in the space between two pairs of eyes? If a glance can build a bridge of understanding, could its absence be the most profound wall of all? Have you ever spoken to someone who refused to meet your gaze and felt a quiet, instinctual alarm bell ring? Or perhaps you've experienced the sudden, warm flood of connection that comes from a few seconds of locked eyes with a stranger, feeling as if a silent, profound understanding has passed between you. That feeling, that unspoken conversation, is not a social construct. It is an ancient, hardwired language written into our very biology, a relic of a time when trust was not a social luxury but a matter of survival. Imagine our distant ancestors living in small, tight-knit bands on the vast and unforgiving savanna. Their world was one of immediate and visceral threats, but also of essential cooperation. The difference between a friend and a foe, an ally and a rival, could mean the difference between life and death. There were no contracts, no written oaths, no digital reputations to check. The only tools for this critical assessment were the senses, the tone of a voice, the set of a jaw, and most importantly, the look in a pair of eyes. The eyes became our first lie detector, our most primal psychological radar. Averted eyes could signal shame, deceit, or threat. A direct, calm gaze could signal confidence, honesty, and alliance. This was not a conscious calculation, but a deep, instinctual reading, a way to peer into the window of another's intentions and see if the soul inside was friend or foe. This ancient instinct is not some poetic metaphor, it is etched into the very architecture of our brains. Evolutionary psychology reveals that when we lock eyes with another person, it triggers a distinct and powerful activation in our prefrontal cortex, the region associated with complex decision-making, social behavior, and crucially, judgments of trustworthiness. It's as if a specific circuit, honed over millennia, lights up to process the data streaming from those two intricate orbs. Fascinating experiments bear this out. In one classic study, researchers simply placed a picture of a pair of watching eyes above an honesty box for coffee payments in a university break room. The result? Contributions increased significantly. There was no real person, no consequence for cheating, just the silent, symbolic pressure of being observed. The feeling of a gaze, even a depicted one, seems to tap into a deep-seated urge to behave in a prosocial, moral way. It whispers to a part of our mind that is always aware of the tribe, always conscious of its judgment. This sets us apart in the animal kingdom. For many creatures, being seen while observing is a moment of vulnerability, or a prelude to conflict, a predator locking on, or prey realizing it has been spotted. For us, it is the foundation of a social contract. We possess a unique, almost paradoxical desire. We want to see, and we want to be seen in the act of seeing. This mutual recognition is the bedrock of complex society. The feeling of being watched compels us to adhere to social norms, to be our better selves, or at least the selves we wish to be perceived as. Conversely, the act of watching back allows us to conduct a rapid, unconscious audit of another's soul. The eyes, therefore, function as a kind of primordial moral sensor, a biological tool for building the trust that allows cooperation to flourish. They are the quiet guardians of social order, the unspoken promise that we are in this together. But is this their only story? If the gaze is the cradle of trust, could it not also be the crucible of deception? The very power of the eyes to signal truth makes them the perfect instrument for a lie. A skilled deceiver knows how to wield a steady gaze, to manufacture the appearance of sincerity, to weaponize the very symbol of trust against us. The eyes can be trained to conceal what they evolved to reveal. This duality forces a deeper question. If we rely so heavily on this ancient channel of communication, what happens when it is taken away? What occurs in the shadowy, silent spaces where eyes cannot meet, and the brain is left to navigate the world half-blind? In the absence of the direct, confirming gaze, does our reality begin to fray at the edges? The human eye, for all its wonder, is not a perfect lens. It captures only a narrow slice of the electromagnetic spectrum, a fragmented view of the world. Our field of vision is limited, filled with blind spots and blurred peripheries. To compensate for this inherent deficiency, the brain does not simply record the world, it actively constructs it. It takes the scant, ambiguous data provided by the eyes and weaves it into a coherent tapestry, stitching together fragments with the thread of memory, expectation, and imagination. We do not see everything that is. We see a story our brain tells us about what is most likely to be there. This is a brilliant, efficient system for navigating a complex world, but it is also a fundamentally creative act. So, when the most trusted source of social data, the direct confirming gaze of another person, is absent, what does the brain conjure in its place to fill the void? What ghosts of suspicion or fantasies of connection does it paint onto the blank canvas of isolation? We do not see the world. Not really, not all at once. We see a sliver, a narrow, fleeting glimpse, a high-resolution sliver of the whole surrounded by a vague, impressionistic blur. Yet, when you look around this room, you feel a sense of completeness. The world does not feel like a collection of fragments. It feels solid, continuous, and whole. This wholeness is the first and greatest magic trick your brain performs for you. It is a beautiful, necessary deception, a story woven in real time from the barest of sensory clues. How is it that we navigate a world so vast with a window so small and never feel the absence of the view? The truth of our vision is hidden in the anatomy of the eye itself. Deep in its center lies the fovea, a tiny pit packed with photoreceptor cells. This is the only place where we see with true, sharp clarity. Its size is almost laughably insignificant, no larger than the head of a pin, a single grain of sand held at arm's length. Everything outside this pinpoint focus dissolves rapidly into a mist of color and motion, a periphery useful for detecting looming threats or sudden movements, but useless for reading the expression on a friend's face or the text on a page. If our conscious experience were a true reflection of our raw visual input, our reality would be a terrifying, disorienting tunnel, a single shining detail adrift in a sea of chaos. But it is not. We experience a panoramic masterpiece. This seamless panorama is not a photograph taken by the eye. It is a canvas painted by the brain. To construct this canvas, the brain employs a relentless, rapid-fire scout, the eye itself. In movements known as saccades, our eyes dart and jump from point to point, sometimes several times a second, unconsciously targeting points of interest. The eyes of a speaker, the edge of a table, a flashing notification. These movements are not smooth scans, but frantic, microscopic leaps. With each landing, the fovea captures a single, crystal-clear snapshot of that specific coordinate. Then it leaps again. The brain, this masterful editor, then takes these disparate, high-definition stamps, a glint of light here, a curve of a lip there, the texture of wood grain, and stitches them together into a coherent whole. It fills in the gaps between these snapshots with an educated guess based on memory, context, and the low-resolution information from the periphery. We are not seeing the present moment as it is. We are experiencing a carefully curated reconstruction of the very recent past. This process is so efficient, so seamless, that we are utterly unaware of the frantic dance happening behind the scenes. The stability of the world is an illusion generated by a system in constant, chaotic motion. This act of construction, however, comes with a fascinating vulnerability. Because our perception is a best-guess narrative and not a direct feed, it can be fooled. Visual illusions are the most direct evidence of this. We see lines bend, that are straight, colors change that are static, objects move that are still. These are not failures of the eye, but rather proof of the brain's success. They reveal the shortcuts and assumptions, the algorithms of perception, that it uses to build our reality quickly and efficiently. It assumes light comes from above, that shadows imply depth, that converging lines mean distance. When these assumptions are manipulated, the brain confidently paints a picture that we know to be false, yet we cannot unsee. It is a powerful demonstration of how much of what we see is actually what we expect to see. The brain does not just receive information, it actively interprets and, when necessary, invents it. In this way, the act of seeing becomes less about reception and more about creation. It is a form of controlled, continuous imagination. Like an artist in a studio, the brain stands before an empty canvas. The eyes deliver scattered sketches, snippets of detail, jars of color. But the final painting, the rich, continuous, three-dimensional world we experience, is a product of the artist's skill, memory, and interpretation. The artist uses its vast library of past experiences to decide how the shadows should fall, how the grass should feel, how a face should look. We are not looking at the world. We are looking at the brain's breathtakingly detailed rendering of the world, projected inside our minds. The world we know and navigate is, in a very real sense, a hallucination, one that is constrained and tethered by sensory input, but a hallucination nonetheless. It is a story we tell ourselves, and we are both the author and the audience. This revelation about our individual perception inevitably casts a new light on our collective existence. If our private reality is a constructed narrative, a fragile consensus between eye and brain, then what of our shared social world? Could it be that our communal life, our cultures, our laws, and our truths are also a collective act of imagination? They are not built from a single objective source of light, but from billions of individual fragmented glimpses stitched together through language, story, and shared belief. We build a common reality from a cascade of saccades, glances, conversations, and observations that we then weave into a shared tapestry. We agree, mostly unconsciously, on what the picture looks like. But what happens when our individual glimpses differ, or when the stories we use to stitch them together begin to fray? We have explored the eye as a biological instrument, but perhaps its truest function is not merely to process light, but to connect us. A look can comfort, accuse, invite, or destroy. It can make us feel seen or painfully exposed. This power suggests that seeing is not a solitary act of perception, but a profoundly social behavior. So, if our gaze is the brush with which we paint our private world, what is it painting onto the canvas of our society? You are looking at someone. Perhaps it's a stranger across a crowded room, a colleague in a meeting, or a loved one over a shared meal. Light enters your eye, striking the retina, a cascade of electrochemical signals firing along the optic nerve to construct an image in your brain. This is the physics of sight, the biology of vision. But this is not what is truly happening. That is merely the mechanism, the hardware. The real event is far more nuanced, a silent, potent transaction. You are not just receiving light, you are sending a message. You are not just seeing, you are seeking to be seen. This simple act, so fundamental we scarcely consider it, is one of our most sophisticated social tools. Across the tapestry of human cultures, the gaze is woven with threads of profound and often contradictory meaning. A direct look can be a challenge, a gauntlet thrown down in the unspoken arena of male social hierarchy. It can be an invitation, a current of electricity in the subtle dance of flirtation. Yet, in another context, that very same directness can be a profound insult, a violation of a sacred social code that demands averted eyes as a sign of respect. This is not a matter of optics. It is a matter of culture. It tells us that to look is a deeply encoded social behavior, a language we learn before we can speak, fluent in a grammar of glances, stares, and avoidances. Social psychology has begun to map this grammar. It reveals that the act of bestowing a look is a primary mechanism for regulating behavior. In a conversation, a glance can command the floor, seat it, or encourage a hesitant speaker. It is the punctuation of human interaction. A sustained gaze can signal intense interest, either in the subject matter or in the person speaking. A flicker of the eyes away and back can communicate doubt, or perhaps a shared secret joke. A mother's look can soothe a child's tantrum without a single word uttered, a silent transmission of security and love. Conversely, a cold, hard stare from a stranger can feel like a physical shove, a territorial claim that instantly puts us on edge. A single glance across a room can either diffuse a building conflict or ignite one. It is a tool that can calm a storm or summon one. This sets us utterly apart from the machines we've built to mimic our vision. A camera lens is a passive receiver. It captures photons. It records data. It does not participate. It does not understand that its gaze is being interpreted. The human eye, however, is never just a lens. When we look, we are engaged in a constant, fluid, and deeply interactive loop. We send a look, we receive one in return, we adjust our own based on the feedback, we synchronize our emotions and intentions. It is a continuous, real-time negotiation of social space. Our eyes are not for seeing alone. They are for connecting, commanding, pleading, and loving. They are a social organ, perhaps our most powerful one. Given this immense power, what are the broader implications of this tool we all wield so instinctively? Could the conscious, deliberate use of the gaze be harnessed for therapy, helping to rebuild the shattered trust of a traumatized mind by offering a safe, accepting look? Can a leader use a shared gaze to unite a fractious crowd, to create a palpable sense of common purpose without a single shouted word? And conversely, how easily can this same tool be twisted to control, to manipulate, to dominate a crowd through fear, where the watchful eyes of authority become a tool of suppression? The potential is vast, residing in the same organ that offers a comforting glance. This power is not a modern invention. Its origins are ancient, written in the most primal parts of our being. If this silent language of the eyes is so deeply embedded in our social fabric, a tool refined over millennia, What becomes of it in the fractured, screen-mediated landscape of modern life? We now communicate through disembodied text and curated images, our eyes glued to glass rectangles that reflect no one else's gaze in return. We have eye contact modes on video calls that artificially simulate a look we cannot truly give, a technological puppet show that mimics a profound human connection. Is this a degradation of an ancient instinct, leaving us lonelier even as we are more connected? Or is it simply an evolution, a new dialect in the same old language? We still desperately seek the validating glance, the like, or the view acting as a digital proxy for being seen. But can a pixelated heart ever truly replace the silent message sent and received in the meeting of two pairs of eyes across a room? Perhaps the most haunting question is this: in a world that increasingly avoids the vulnerability of a real, held gaze, what unspoken truths are we no longer able to tell? The screen glows, a mosaic of faces in digital tiles. A voice speaks, clear and crisp through the headphones. The words are correct. The information is exchanged. The meeting's agenda is dutifully checked off. And yet, a strange, persistent emptiness lingers. It's a meeting that has happened, but a connection that has not. The cursor blinks in the silent chat box. The presentations are flawless, but something vital is missing, something we only notice by its profound absence. The meeting of eyes. We have never been more technologically connected, and yet we are quietly starving for a truly shared gaze. We have built a world of instant contact that somehow sidesteps the very thing that first taught us we were not alone. Long before the first word was ever grunted, before the concept of a sentence could even be formed, our world was built and understood through the eyes. In the dim, vulnerable light of a prehistoric cave, a mother would lock eyes with her newborn. In that silent exchange, a universe of meaning was transmitted. Safety, recognition, a primal bond that whispered, "You are mine, and I am here." A leader, standing before the tribe, would sweep his gaze across the gathered faces. That look was not a request for attention. It was a tool of cohesion. It assessed understanding, projected confidence, and forged a silent pact of mutual purpose. It asked a question and gave an answer simultaneously. Are you with me? I am with you. This was our original language, a dialect of the soul spoken in a glance, a widening of the pupil, a momentary squint. Our ancient brains became hardwired to read these microsignals, to find truth and intention not just in words, but in the windows of the face. We carry that ancient hardware into our modern, fluorescent-lit world. Our neocortex might understand the logic of a Zoom call, the efficiency of an email, but the older, deeper parts of our brain, the limbic system, the seat of emotion and social processing, remain unconvinced. It waits patiently for the data it was designed to receive. Functional MRI scans reveal this neural dissonance with startling clarity. When two people converse in person, engaging in natural eye contact, the brain lights up like a city at night. A complex dance of neural activity erupts in the prefrontal cortex, the temporoparietal junction, and the amygdala, regions responsible for empathy, inferring another's thoughts and feelings, and building social bonds. The brain is doing its most essential work, connecting. Now, observe the same brain during a video call. The activation is different, dimmer. The social circuitry flickers with less intensity. The brain receives the image of a face, but the signal is incomplete. The gaze is misaligned. We look at the screen, not into the camera, creating a perpetual, unsettling feeling of looking slightly past one another. The subtle subconscious cues are lost in compression artifacts and a frozen frame. The conversation becomes a transaction of information stripped of its emotional subtext. Trust is harder to build. Nuance is easier to miss. A joke can fall flat. Concern can seem distant. We are speaking, but we are not fully seen. And so we find ourselves in this peculiar tension. We celebrate our powerful tools. The ability to host a global team meeting in slippers, to send a thought across an ocean in milliseconds. The convenience is undeniable, a marvel of human ingenuity. But it is a marvel that often leaves us feeling curiously malnourished. We scroll through hundreds of faces on social media, yet we can feel a deep, isolating loneliness. We react with emoji, a laughing, crying face, a heart, a thumbs up, tiny, cartoonish substitutes for the human responses they represent. They are a brave, clumsy attempt to replicate the warmth of a crinkled eye smile, or the empathetic softening of a gaze that says, "I understand your pain." But they are a translation, and like all translations, something of the original essence is lost. The emoji is a symbol. The eye contact is the experience itself. There is no algorithm that can replicate the jolt of electricity that passes between two people when their eyes meet across a crowded room and a silent understanding is forged. There is no filter that can simulate the profound comfort of a friend's steady gaze during a moment of grief, a look that says more than any string of condolences ever could. The eyes are not merely organs of sight. They are conduits of our humanity. In a world that increasingly mediates our interactions through screens and text, the simple, unadorned act of looking someone in the eye feels almost radical. It is an act of vulnerability and courage. It is a silent pledge of authenticity in a sea of curated personas. It is the ancient, irreplaceable handshake of the soul, reminding us that beneath the layers of technology and civilization, we are still creatures yearning for the undeniable truth of a shared look. This truth, however, holds a paradox at its core. For if the gaze is our primary tool for connection, our most fundamental bridge to another consciousness, why does it also hold the power to unnerve us so completely? Why does the unbroken stare of a stranger on a subway car make our skin prickle with a deep, instinctual alarm? The same tool that builds trust can also be wielded to dismantle it. The eyes that cradle can also club. The very channel that carries empathy can, with a slight shift in focus, transmit a threat. This duality is written into our deepest biology, a leftover script from a time when being seen was not always a prelude to connection, but often a precursor to conflict. So if the mutual gaze is the bedrock of our social world, what ancient ghost is stirred when the gaze becomes a one-way street, a sustained and searching scrutiny? What primordial line do we cross when connection curdles into surveillance and the windows to the soul become something else entirely? Have you ever felt a sudden chill, a primal unease that crawls up your spine, for no reason other than the certain unshakable knowledge that you are being watched? In a crowded subway car, on a deserted street, or even in the supposed safety of your own home, the weight of an unseen gaze can trigger an immediate visceral reaction. Your muscles tense, your heart rate quickens, your senses sharpen to a fine point. No one has touched you. No explicit threat has been made. Yet, your body responds as if a predator has just emerged from the shadows. Why? Why does something as intangible as a look carry the power to unnerve us so completely, to make the most modern human feel like a cornered animal? This profound discomfort is not a flaw in our modern psyche, but rather an ancient feature, a deeply engraved line of code in our operating system that has been running for hundreds of thousands of years. To understand it, we must journey back to a world without streetlights or walls, where the horizon was a line of endless danger and opportunity. For our distant ancestors, survival was a perpetual game of observation. To see first was to eat. To be seen first was to be eaten. In that primal theater of life, the gaze was never neutral. It was either a weapon or a warning. The intense, focused stare from the undergrowth was rarely one of curiosity. It was the prelude to an ambush, the final calculation of a predator, be it leopard, lion, or rival hominid, before it sprung. Conversely, to catch the gaze of another from your own tribe was to engage in a complex dance of social hierarchy, a challenge for dominance, or a test of alliance. In this context, being stared at was synonymous with being targeted. It was the sharp end of a very real spear. This history is not forgotten. It is etched into the very architecture of our brains. The moment you sense you are being watched, a tiny almond-shaped cluster of neurons buried deep within your temporal lobes, the amygdala, screams a silent alarm. This is the command center for fear, the trigger for our most famous survival instinct, fight or flight. It operates on a timeline far older and faster than conscious thought. It doesn't think. It reacts. It bypasses the rational modern cortex that knows you are in a coffee shop, not a savanna, and sends urgent signals directly to your body. Cortisol and adrenaline flood your bloodstream. Your pupils dilate to take in more visual information. Your body is mobilized for a threat that, in all likelihood, does not exist. Your logical mind might later dismiss the feeling as paranoia, but your body, in that moment, is absolutely certain. It is responding to the ghost of a predator that vanished millennia ago, a ghost whose only remaining weapon is the unsettling power of a direct stare. We have built a world of astonishing complexity, a labyrinth of glass, steel, and digital light, yet we walk through it with a nervous system designed for the wilderness. The ancient fear of the gaze has simply found new costumes in which to perform. The unblinking eye of a security camera in a department store, its red light a steady, indifferent pupil, can evoke a faint echo of that old vigilance. In a silent examination hall, the proctor's slow, sweeping scan of the room is not so different from an alpha monitoring the pack for signs of weakness or deception. The intense, judgmental stare from a stranger across a silent elevator. What is it they want? Why have they chosen to focus on me? These modern scenarios lack the immediate physical peril of a leopard's stare, yet they tap into the same deep-seated neurological river. Our social world is built upon a constant, nuanced exchange of glances. Averted eyes show submission. A steady gaze can show confidence or aggression. A shared look can build instant intimacy. To have a stare break these unspoken rules, to have it linger too long or hold too much intensity, feels like a transgression. It is a social threat that our brain, ever the opportunist, processes through the oldest filter it has, the filter of survival. Is this new world of constant potential observation making us more vigilant? Or is it simply stretching an ancient fear to its breaking point? And yet, for every rule, there is an exception written in the same ancient ink. For every moment, a gaze feels like a threat. There is another where it feels like a sanctuary. Perhaps the story is not just about the fear of being seen, but about the primal, aching need to see together. Imagine the first humans, huddled not just for warmth, but for courage in the face of a terrifying and incomprehensible world. In the flickering firelight of a cave, shadows danced on walls, and the unknown loomed in every echoing drip of water. What did they do? They turned their eyes not toward the darkness at the back of the cave, but toward the blank stone canvas. And there, with charcoal and ochre, they began to make the unseen scene. They painted the beasts they feared and revered. They created a shared point of focus, a communal gaze. To look upon the painted bison was to collectively externalize the fear, to objectify it, and in doing so, to master it. That shared gaze became the foundation of myth, of ritual, of story. It was the first act of collective meaning-making. The gaze, which could be so threatening when directed at you, became the very source of connection and safety when directed with you toward something else. It transformed from a weapon into a cradle. So we are left suspended between these two poles of a single powerful sense. The same eyes that can freeze us in fear can also hold us in understanding. The same neural circuitry that primes us for flight can also open us to empathy. We are heirs to both the watchful prey and the collaborative storyteller. We navigate a modern landscape with a prehistoric compass, forever sensitive to the weight of a look. Is our deep-seated unease, then, the price we pay for the profound comfort of a shared vision? And if our civilization was indeed born in that first moment we chose to look together at a drawing on a wall, what does it mean that we now spend our days staring into countless individual glowing screens, each one reflecting a different solitary world? More than 30,000 years ago, a hand stained with ochre and charcoal reached out and touched the cold, unforgiving rock of a cave wall. It did not seek to decorate an empty space, it sought to resurrect. In the flickering, anxious light of a tallow lamp, the bison emerged from the stone, a massive, breathing silhouette frozen in a moment of primal tension. This was not mere observation, it was an act of conjuring. To see was to survive, but to re-see, to capture and command the image of a thing that was no longer there, that was something else entirely. It was memory. It was story. It was the first fragile declaration that human experience was too precious to be lost to the relentless march of time. The eye had become more than an organ. It had become a gateway, and on the walls of those deep, dark sanctuaries, we began to build our first civilization of light and shadow. Places like Lascaux in France or Altamira in Spain are not simply galleries of prehistoric art. They are cathedrals of early consciousness. To stand within them is to feel a profound silence, a weight of ages, punctuated by the ghostly echoes of a fire's crackle and the soft, determined scratch of stone on rock. The images themselves, aurochs with thunder in their shoulders, horses caught in mid-flight, abstract patterns that might map the stars or the tremors of a shaman's vision, speak of a mind that is recognizably our own. These artists were not doodling. They were engaged in a sacred, desperate dialogue with their world. They did not just want to observe the beast. They needed to possess its essence, to understand its power, by rendering it, by fixing its fleeting form into a permanent state of being seen. This act of preservation was also an act of sharing. The image was a story that could be told without words, a lesson that could be passed from one generation to the next, a vision that could be collectively experienced under the veil of darkness. It was the original cinema, a communal dreaming onto stone. In this profound darkness, illuminated only by the precarious dance of flame, vision became the bedrock of both art and the sacred. The flickering light did not simply reveal the paintings, it brought them to life. The uneven glow made muscles seem to twitch and shadows appear to deepen, animating the still images with a breath of the uncanny. This was not a passive viewing experience, it was a participatory ritual. The viewer, perhaps a young initiate learning the paths of the hunt, or a tribe seeking the blessing of the spirit world, was not separated from the world being seen. They were drawn into it. The painted hunt became a prelude to a real one, the depicted animal spirit, a conduit to its real-world counterpart. This was a direct transfer of emotion and meaning, a visual contract between the human and the non-human world, mediated by the skilled hand and the watchful eye. Sight was the thread that connected the tangible present with the intangible past and the hoped-for future, weaving together fear, respect, awe, and necessity into the fabric of early culture. From those torch-lit caves to the air-conditioned darkness of a modern movie theater, the fundamental impulse remains eerily unchanged. We still gather in the dark, a collective of strangers, to fix our gaze upon an illuminated surface and experience a shared vision. The technology has evolved from pigment and rock to light and pixel, but the underlying architecture of the experience is a direct inheritance. The jump cut is the new shaman's trance. The CGI beast is the new spirit animal. The actor's close-up is the new communal face of emotion. We still use these crafted visions to make sense of our world, to explore the edges of what we know, to feel terror and joy in a safe container, and ultimately, to understand each other. The eye is no longer a passive tool for navigating the physical world. It has become the undisputed center of an entire visual civilization, the primary channel through which we receive story, information, and our very sense of reality. We cry at a sunset in a film. We flinch at a fictional threat. We learn about deep space from a digital animation, all because our eyes willingly accept the illusion and our minds complete the enchantment. But this journey from the cave wall to the silver screen begs a deeper, more ancestral question. We speak of the human eye as a constant, a biological camera that has simply recorded an improving world. But is that true? To truly understand the power of this gateway, we must ask not what we have looked at, but what we have looked with. What was the instrument itself like at the dawn of our seeing? The paintings at Lascaux are a testament to a modern human mind, but the eyes that guided those hands, were they the same as ours? Or were they inherited from a much deeper, darker past, shaped by eons of a different kind of survival? If we could peer back beyond the first paintings, beyond the first stories, beyond even the first words, what would we find looking back at us from the depths of time? The answer lies not on a painted wall, but in the empty socket of a fossilized skull. What world was reflected in the eyes of the first who saw, not to create, but simply to survive? If you were to hold the skull of a Homo erectus in your hands, your fingers would trace the deep, prominent brow ridges, the sloping forehead, the cavernous orbits that once cradled a living gaze. What did those eyes see? Was their world a blur of survival, a stark panorama of threat and opportunity? Or did it hold, in its dawn-lit moments, a flicker of the wonder we know today? The silent architecture of bone offers no easy answer, only a profound invitation to look back through time, into the darkness of those empty sockets, and begin to imagine. Places like Dmanisi in Georgia, where the Eurasian wind whispers across ancient volcanic rock, or the fertile soils of Sangiran in Indonesia, and the deep labyrinthine caves of Atapuerca in Spain. These are the keepers of our ocular history. Here, the earth has yielded up a gradual, unmistakable record written in fossilized bone. We see the orbit itself evolving. From the smaller, shallower, more sideways-facing sockets of our earlier ancestors to the larger, forward-facing cups of Homo erectus. This is not a random shift. It is a meticulous redesign, a slow-motion pivot of the entire skull that reoriented our lineage's window onto the world. This architectural change marks a fundamental renegotiation with reality, a shift from a world perceived primarily through smell and sound to one dominated by sight, a transition from being a creature in a landscape to one that began to observe it. This revolution in vision is inextricably linked to a revolution in posture. As our ancestors descended from the trees and began to walk upright across the expanding savanna, the horizon itself changed. The world flattened and stretched out before them. No longer was the primary concern what might be lurking above or immediately behind. The new imperative was to see what was ahead, far in the distance. The forward-facing position of the eyes, a trait known as stereoscopic vision, was the key. It allowed two slightly different images from each eye to be woven together in the brain into a single, seamless picture endowed with depth and dimension. This was a critical upgrade. It turned the world from a flat painting into a sculpted, navigable space. It allowed a hominin to judge the distance to a watering hole, the depth of a ravine, or, most crucially, the trajectory of a thrown spear or the fleeting movement of prey. This depth perception was not merely a hunting tool. It was a social catalyst. To coordinate a hunt, to pass a tool hand to hand, to gauge the intention in another's posture, all of this required a precise, shared understanding of a three-dimensional world. The eyes, in their new alignment, became the primary instrument of a new, collaborative existence. To understand the profundity of this shift, we need only glance at our fellow inhabitants of Earth. A baboon, with its eyes positioned on the sides of its head, possesses a nearly 360-degree field of view. It is a master of peripheral vigilance, its world a panoramic screen alerting it to any approaching threat. A rabbit lives in a similar world of constant watchfulness, its survival depending on seeing the predator before the predator sees it. Their reality is one of escape. Our ancestors, by contrast, were crafting a reality of engagement. We sacrificed that panoramic view for a focused, binocular one. We traded the ability to see a lion coming from all directions for the ability to throw a rock at it with deadly accuracy, or to quietly conspire with a companion on how to avoid it altogether. The deep-set human orbit, then, tells a story of a creature moving from a life defined by the role of prey to one increasingly embracing the roles of predator, planner, and partner. Is our very perception of reality, then, not just a biological recording, but a chosen strategy for survival? Yet, to see the evolution of the eye socket as a purely functional adaptation for better hunting or foraging is to only read the first page of a much deeper story. The bones changed, yes, but the soft tissue they protected and the social world they enabled changed even more dramatically. The reconfiguration of the skull did more than just allow for better depth perception. It created a new stage for communication. The forward-facing eyes became beacons of intention, and the surrounding architecture, the newly structured forehead, the reduced brow ridge, the complex musculature of the face, evolved not just to protect the eye, but to frame it, to amplify its silent language. In the shadows of those sockets, the eyes gained a new power, the power of expression. A subtle squint, a widening of the eyes, a meeting of gazes. These became units of social currency more nuanced than any grunt or gesture. The eye became more than an organ of sight. It became an instrument of connection, a window not just onto the world, but into the mind behind it. Could it be that we learn to see with each other before we fully learn to talk to one another? So we are left with a paradox etched in bone. The orbital socket, this architectural marvel, evolved for the brutally practical needs of survival in a physical world, to judge distance, to spot food, to avoid death. Yet, in doing so, it inadvertently gave birth to the most intimate and elusive aspects of the human experience: empathy, shared attention, and the silent poetry of a glance. It is the cradle of both the hunter's calculating stare and the lover's tender gaze. The hollowed bone is a frame, but what it framed was the beginning of a soul. And so we must ask, did the eye evolve to see the world, or to finally allow the world to see us? When you raise an eyebrow in skepticism, squint in concentration, or widen your eyes in astonishment, you are performing a minor evolutionary miracle. You are speaking without words. This intricate ballet of facial muscles, centered around the windows to your soul, is a language far more ancient and universal than any spoken tongue. It is a silent symphony of social connection, a tool of survival, forged not in the harshness of the wild, but in the complex, burgeoning world of human interaction. But why would evolution select the eye, of all organs, to become such a potent instrument of expression? Why transform the primary tool for gathering information into the primary canvas for broadcasting our innermost states? The human eye socket, or orbit, is not merely a hollowed-out bone to safely cradle a delicate globe. It is a masterpiece of architectural engineering, sculpted by millions of years of social pressure. Unlike the orbits of our closest primate cousins or our extinct Neanderthal cousins, ours are uniquely positioned and structured. They are not just wide but also recessed, set deeper into the skull beneath a high, vertical forehead. This recession creates a protected stage, a defined arena around the eye itself. It clears the space necessary for the surrounding facial muscles to contract and relax with unparalleled freedom and subtlety. The prominent, mobile eyebrow, a feature largely unique to modern humans, acts as a punctuation mark above this stage, capable of arching, lowering, and knitting together to convey a vast spectrum of nuance, from curiosity to concern, from recognition to threat. Beneath the skin, an intricate network of specialized muscles operates this machinery of meaning. Consider the orbicularis oculi, a sphincter muscle that forms a tight ring around the orbit. Its gentle contraction gives a genuine, crinkly-eyed smile its warmth. Its forceful closure protects the eye from danger or signal intense distress. Then there is the levator palpebrae superioris, a delicate muscle that acts like a curtain pulley, raising the eyelid to reveal attention or lowering it to feign disinterest or hide fatigue. And perhaps most telling is the corrugator supercilii, the small, powerful, frowning muscle that pulls the eyebrows down and together, etching vertical lines of worry, concentration, or anger onto the forehead. This complex is our biological toolkit for social signaling. Neanderthals, for all their intelligence and strength, possessed a different facial architecture, a prominent brow ridge, a more sloping forehead, and less developed musculature around the eyes. Their gaze, while likely intelligent, was arguably less legible, their emotional states harder to read at a glance. This anatomical difference hints at a profound divergence in our evolutionary paths, one favoring raw power and resilience, the other leaning into the power of connection and communication. This communicative power is instantly recognizable, even across the species barrier. A dog may not understand the words of its owner, but it is an expert at reading the language of the eyes. It sees the softness of a relaxed gaze signaling affection, the hard stare of disapproval, the wide-eyed excitement before a walk. This is a dialogue built on millennia of coevolution, where the human capacity for expressive clarity found a willing interpreter. In stark contrast, the eye of a crocodile is a purely functional instrument. It is a sophisticated sensor for detecting movement and judging distance in the water, but it is a locked door. It offers no window into any internal state, if such a state even exists in a comparable way. It cannot plead, threaten, or sympathize. The human eye, however, is a dynamic display, a high-resolution screen broadcasting our emotional reality in real time. This ability to project and to perceive such subtle cues is the bedrock of empathy, a near instinctual resonance that allows us to feel what another is feeling, to coordinate, to care, and to build societies based on mutual understanding. Yet, this evolutionary innovation, this transformation of the eye into an emotional beacon, forces a deeper, more philosophical question. The eye's position itself, front and center in the face, is the foundational prerequisite for this entire story. But was this placement itself a biological mandate for better vision, or was it, from the very beginning, a behavioral strategy waiting to happen? If the orbit was the frame and the muscles the brush, was the stage itself the forward-facing gaze, set up not just to see the world, but to be seen by it? The very architecture that allows us to perceive depth and hunt prey also forces our most intimate expressions into the direct line of sight of others. This convergence of function is too perfect, too coincidental. It suggests that the story of the eye is not two separate tales, one of vision, one of expression, but a single, intertwined narrative. What deeper truth, then, does this physical convergence reveal? If our eyes are positioned to see the world in 3 dimensions, does their placement also force us to present our own inner dimension, our vulnerabilities and intentions, for the world to see in high definition? Is the price of perfect stereoscopic vision a complete and utter lack of emotional privacy? Have you ever noticed, in a moment of quiet observation, the fundamental difference between the gaze of a rabbit and your own? The rabbit, a soft tremor of life in the field, sees a world that stretches nearly 360 degrees around its head. Its eyes, set on the flanks of its skull, are wide portals to a panoramic reality, a constant sweeping vigil for the shadow of a hawk or the rustle of a fox. Now meet your own eyes in the mirror. They are set close together, facing forward, 2 lenses focused on a single shared reality. This is no accident of form. It is a story, written in bone and nerve, a profound declaration of a way of life. The placement of the eyes is an evolutionary signature, a direct testament to the ancient, unending dialogue between the hunter and the hunted, and perhaps to the very origins of our humanity. This is a story of perspective, in the most literal sense. For an animal whose life depends on not being eaten, vision is not about depth, it is about breadth. The wide-set eyes of prey animals like deer, horses, and rabbits provide an immense field of view. They sacrifice the world in front for the world around. There are blind spots, certainly, directly in front of the nose and behind the head, but the trade-off is a near-complete sphere of awareness. A predator can hardly twitch in the periphery without triggering a flight response. This vision is a defensive perimeter, an early warning system built into the architecture of the skull. It is a life lived in the panoramic, a constant anxious scan of the horizon for the slightest hint of a closing circle. Their world is flat, wide, and defined by the threat of what may be coming from the side or behind. Now, consider the gaze of the predator, the wolf, the owl, the tiger, and us. Our eyes are locked in a forward-facing stance. This configuration is the hardware for a software called stereoscopic vision. Each eye captures a slightly different image of the world in front of us. Our brain then performs a breathtaking feat of computation, overlaying these two images and calculating the infinitesimal differences between them. The result is depth perception. We do not just see a world of shapes and colors, we navigate a world of precise distances. We judge the gap between branches, the depth of a river, the exact distance to a grazing animal. This is vision as a targeting system. It is the difference between seeing a branch and knowing you can grasp it, between spotting a rabbit and knowing your spear will find its mark. For a hunter, success is measured in millimeters and milliseconds. That forward gaze, that binocular overlap, is the difference between a feast and famine. The evidence for this evolutionary strategy is etched into our very bones. Paleoanthropologists, studying the fossilized skulls of our ancestors, can trace the gradual migration of the eyes. In early hominins, the skull structure suggests a field of view more akin to our primate cousins, with a wider set. But as the genus Homo emerged, as we began to walk upright, and our hands were freed not just for carrying but for crafting and throwing, the architecture of the face changed. The snout receded, and the eyes rotated forward, narrowing the angle between them. This was not an aesthetic choice. It was a technological one. This new vision enabled the sophisticated hand-eye coordination required to fashion a stone tool, to hurl a spear with deadly accuracy, to imagine an arc through the air and then execute it. Our sight became an extension of our intent, a tool for acting upon the world with precision and force. We became hunters not just of muscle, but of mind and calculation. Yet, here we are today, most of us far removed from the act of the hunt. The supermarket aisle has replaced the savannah, and the most dangerous predator we typically face is the morning commute. So why did we keep this hunter's gaze? The answer lies in a different kind of wilderness, one just as complex and perilous: the social world. Our prey transformed. We are no longer tracking antelope through tall grass. We are tracking intentions, emotions, and social cues through a landscape of conversation and interaction. Our forward-facing eyes, with their exquisite sensitivity to depth and detail, became perfectly repurposed for reading the most subtle of signals: the slight tightening around a friend's mouth that betrays a worry, the micro-shift in a colleague's pupils that signals deception, the soft, warm crinkle at the corner of a lover's eye that speaks of joy. This stereoscopic vision is the foundation of empathy. It allows us to look into another's face, to focus on their expression, to truly see them. We are, in a sense, emotional hunters, and our eyes are the tools with which we navigate the intricate and invisible terrain of human connection. We seek the truth behind the words, the feeling behind the facade. Our survival now depends less on outrunning a predator and more on understanding a partner, predicting a rival, or comforting a child. The same eyes that once calculated the trajectory of a spear now calculate the trajectory of a social bond. Is it possible that our greatest evolutionary advantage was not just in turning our eyes forward to hunt, but in turning them toward each other to build trust? This leads us to a fascinating and deeply human capability, one that is utterly dependent on our forward-facing gaze: shared attention. It is the ability to follow another's line of sight, to understand that they are seeing something, and to know that they know you are seeing it too. When you point to a bird in a tree, a dog might look at your finger. A human child will follow the line of your finger to the bird and then look back at you, creating a triangle of connection: you, me, and the thing we are both seeing. This is the cradle of language, culture, and cooperation. It is the mechanism that allows us to collaborate on tasks far more complex than any solitary predator could ever manage. To build a boat, Govern a city or compose a symphony requires that we can all be looking at the same problem, the same dream, the same point on the horizon. Our forward-facing eyes did not just make us better individual hunters, they made us a collective force. They allowed us to create a shared world, a common ground of understanding that extends far beyond the immediate threat or the available food. We became a species that could point to the stars and say, "Let's go there," and know that the person beside us was seeing the same destination. The story of our eyes is therefore not just a tale of predation, but a prologue to society itself. It suggests that the very tool that made us effective killers may also be the very tool that made us profound collaborators. So, if the eyes are the window to the soul, what does it mean that our windows are designed to focus, together, on a single point? And what becomes possible when millions of us choose to focus on the same thing? You look up at the sky, for no reason at all. Perhaps a passing cloud caught your eye, or a distant bird, and then you notice it. Someone nearby, a stranger perhaps, has followed your gaze. Their head tilts upward, their eyes scanning the empty blue, searching for what you saw. They don't know why they're looking. They only know that you are. This is not a meaningless reflex, a simple tick of social behavior. It is a silent testament to one of our species' most profound and overlooked gifts, the innate, irresistible urge to follow another's gaze. It is the bedrock upon which we have built everything. In the deep time of our ancestry, survival was a collective endeavor. We did not face the savannah alone. In small, tight-knit bands, the ability to see what others see was not a parlor trick. It was a matter of life and death. A sudden shift in a companion's focus, a sharp intake of breath, eyes widening and locking onto a point in the tall grass. This was the only alarm system we had. It meant predator. It meant prey. It meant danger or opportunity, arriving without a sound. This shared attention extended beyond immediate threats. It was around the first controlled fires, where eyes reflected the dancing flames, collectively witnessing the mystery of light in the darkness. It was in the communal observation of a painted symbol on a cave wall, a shared belief made manifest in a shared line of sight. To see together was to know together, to be part of a unified cognitive unit, a single mind distributed across many bodies. Neuroscience has since illuminated the biological machinery behind this silent communion. We are not merely learning this skill. We are born wired for it. Deep within the social brain, a specialized network of neurons dedicates itself to the intricate task of gaze processing. Regions like the superior temporal sulcus act as a sophisticated tracking station, calculating the angle of a head, the direction of the eyes, and the subtle language of the eyebrows. This system, so finely tuned in Homo sapiens, allows us to infer the inner world of another, their intentions, their desires, their knowledge, from the barest flicker of their gaze. It is a form of silent, high-speed telepathy, a bridge built not of words, but of perception. We call this gaze following, and while glimpsed in our closest primate relatives, it blossoms in us with a complexity that is uniquely human. It is the invisible thread that connects individual consciousness into a shared tapestry of understanding. Consider the solitary hunter, the leopard. Its success is a masterpiece of individual focus, a singular will pitted against the world. Its eyes are tools for it alone. Now, contrast this with the ancient human hunt. It was a symphony of coordinated attention. One hunter freezes, his body tense, his eyes locked. Another follows his gaze, then another. A nod, a silent signal, and the trap is set, not with shouts, but with looks. This same ancient capacity for visual alignment now operates in our modern world. A teacher holds the attention of 30 students, their eyes collectively following a line of equations on a board. A conductor lifts a baton, and the musician's gaze converges, ready to breathe life into the same first note. A team of engineers gathers around a blueprint, their shared focus a tangible force, solving a problem not as individuals, but as a single organism with many eyes. Our ability to build cathedrals, launch rockets, and compose symphonies begins with this most fundamental act, looking in the same direction. Yet, like any powerful tool, this bridge of shared sight can be crossed by shadows. The very trust we place in another's gaze, a trust baked into our neurology over millennia, creates a vulnerability. If the eyes are a window to the soul, what happens when that window is crafted to deceive? What if the signal of shared attention could be hijacked, turned from a cradle of cooperation into a club of manipulation? The answer may lie in a subtle, almost imperceptible dilation. We think we control our eyes, but do we truly command the tiny black circle at their center? The pupil, that gateway of light, responds to more than just the sun. It is an honest messenger from the autonomic nervous system, betraying interest, arousal, and effort. When we see something we desire, something that captivates us, our pupils dilate, allowing more light in, as if trying to consume more of the world. This is biology. But we are storytellers, pattern seekers. Over time, we began to read this biological signal as a social one. A widened pupil was unconsciously perceived as a sign of engagement, of fascination, a nonverbal, "I am captivated by you." And so, a feedback loop was born. A biological response became a social cue. But can a cue become a costume? If a dilated pupil signals attraction and focused attention, could one learn to fake it? The history of beauty is littered with the attempt. In the Renaissance, Italian women used drops of deadly nightshade, belladonna, to artificially dilate their pupils, to appear more alluring, more enthralled. They were manipulating the oldest signal of trust we know, turning a reflexive truth into a calculated fiction. They were hacking the gaze-following instinct, planting a false signal that whispered, "Look at me, for I am utterly focused on you." It was a dangerous gambit, using poison to mimic passion. This is the paradox of our shared gaze. The very mechanism that allows for profound cooperation and empathy also opens a door to the most intimate form of deception. We are wired to trust the eyes above all else, but what do we see when we stare into a pupil that is lying? So, we are left to wonder, is the dilated pupil a master of deception, or merely its puppet? Is it a conscious tool of manipulation, or an unconscious biological event that we, the observers with meaning, weaving a narrative of intention around a simple act of light? The gaze that binds us together, that built our civilizations. Can that same gaze be the very thing that pulls us apart, leading us not toward shared truth, but into a shared illusion? If our greatest strength is our ability to see through another's eyes, what happens when we cannot trust what we see? Have you ever looked into someone's eyes and felt an inexplicable pull, a sudden sense of closeness, as if a silent, unspoken conversation had just begun? They might not have said a word, yet you felt a shift. It's a subtle phenomenon, a fleeting dilation of the pupil, a dark circle expanding like a tiny, welcoming universe. This is not a trick of the light, but a trick of the mind, a biological whisper that speaks volumes in the quiet language of attraction and connection. The eyes, we are told, are the windows to the soul. But perhaps they are first and foremost a window to the autonomic nervous system, a real-time display of our most primal reactions, broadcasting signals we learn to read long before we learn to speak. This involuntary response, the pupil's expansion and contraction, is a dance choreographed by the most ancient parts of our brain. In low light, the pupil dilates to capture every available photon, a simple, mechanical adjustment for survival. But its behavior is far more complex, a delicate instrument tuned not just to the physical environment, but to the emotional one. A surge of interest, a spark of fascination, the quiet thrill of seeing something or someone profoundly appealing can trigger the very same response. The pupil betrays our inner state, widening as if to take in more of the object of our desire, to drink in the details of a face that captivates us. It is a silent, unconscious confession of attraction, a biological truth told in the absence of a lie. Throughout history, Long before the advent of modern psychology or neuroscience, this unspoken signal was intuitively understood. Renaissance painters, masters of human nuance, subtly enlarged the pupils of their subjects to imbue them with a lifelike warmth and vitality, a mysterious allure that viewers felt but could not name. In the dimly lit courts of past centuries, across candle-lit tables, this dilation could signal interest across a crowded room, a private message sent in a public space. It was a form of communication that bypassed language, etiquette, and social constraints. A raw, unfiltered glimpse into another's interest or intention, a shared secret held in a glance. Modern science has begun to map the contours of this silent language. Research reveals that the human brain is a remarkably adept, if unconscious, interpreter of pupillary signals. When we observe a dilated pupil in another, our own brain responds with a faint echo of trust and approachability. We perceive that person as more open, more interested, and more attractive. This creates a feedback loop of mutual positivity, a nonverbal dance of reciprocity where one person's unconscious signal triggers another's unconscious welcome. It is the biological foundation of a spark, the glue of a nascent bond, all happening in a fraction of a second beneath the surface of our awareness. It feels like magic, but it is physiology. It feels like soul, but it is chemistry. So, if our brains are so finely tuned to this signal of connection, does that mean we are hardwired for trust? Yet, this biological signal is profoundly ambiguous, a word with multiple meanings in its silent lexicon. For the very same pupil that widens with attraction also dilates in fear, in rage, in sheer panic, or under the crushing weight of grief. It is the eye's response to any peak of arousal, whether that peak is the summit of desire or the abyss of terror. The same eyes that seem to invite you in could, in fact, be signaling a desperate urge to flee. This is the pupil's paradox. It reveals intensity, but it conceals the emotion's true color. It tells us that something is happening, but it lies about exactly what. This ambiguity transforms the human gaze into a potential theater for deception. The skilled manipulator, the compelling liar, might feign interest, but can they consciously command their pupils to dilate on cue? And the astute observer, the one who reads these microsignals, gains a powerful advantage: the ability to potentially sense the shadow of fear behind a confident smile or the cold calculation behind a warm gaze. This is the high-stakes game of social cognition, where reading the eyes becomes an art form of survival. But if the same signal can mean either invitation or threat, how can we ever be certain of what we see? This uncertainty forces us into a dangerous and fascinating territory, a liminal space between perception and belief. We want to trust our eyes. We are built to believe what they tell us. But they are not neutral observers. They are interpreters, guided by a brain that is desperate to make sense of the world, often preferring a quick guess to a slow truth. We see the dilation and we feel the connection, layering our own hopes and narratives onto a biological event that could have a dozen different causes. We are, in that moment, believing in an illusion crafted by our own mind, a story we tell ourselves based on an unreliable narrator. The gaze becomes a mirror, reflecting not the truth of the other, but our own desire to connect, to be seen, to be chosen. So, when the eyes themselves can be so duplicitous, either by biological accident or conscious design, what anchors our reality? Is it the cold, hard facts of physiological response, or the warm, subjective feeling of a shared glance? And this brings us to the most unsettling question of all. If our perception of such a fundamental signal is so easily warped by context and expectation, how much of what we see is ever truly there? The human eye is not a flawless camera. It is a partner to a brain that has learned to predict, to assume, to complete the picture based on past experience. We do not see the world as it is, but as a best-guess simulation constructed in the dark theater of our skulls. The pupil's dilation is a fact. Our interpretation of it is a story. And in the gap between the two resides the entire, beautiful and terrifying, potential for human connection and misconnection. So, we are left with a lingering thought, a quiet wonder that hangs in the air long after the glance is broken. If the very tool we use to perceive truth is itself a source of illusion, then what does it mean to truly see another person? Are we ever looking at them, or are we merely seeing the reflection of our own mind's desperate, beautiful predictions? Have you ever stared at one of those swirling, hypnotic optical illusions? The kind where a static image appears to pulse and breathe with a life of its own? Or perhaps you've experienced the fleeting, unsettling moment of seeing a face in a crowd, certain you know it, only for the recognition to dissolve into anonymous features. These are not mere glitches in your perception. They are windows. They are the subtle, everyday tremors that hint at a profound seismic truth beneath the surface of our consciousness, that what we call seeing is not a passive recording of the world, but an active, relentless, and deeply personal act of creation. Our eyes are not impartial witnesses. They are eager collaborators in a story the brain is desperate to tell. This collaborative process begins not with clarity, but with lack. The human eye is not a perfect, high-resolution camera lens capturing a complete and unbiased picture. It is more like a hurried scout in a vast and complex landscape, sending back fragmented, incomplete reports. The most telling evidence of this is your blind spot, that small area in each retina where the optic nerve exits, creating a literal hole in your field of vision with no light-detecting cells. You don't walk around with two black holes perpetually in your sightline because your brain, the master editor, seamlessly paints over them. It uses the surrounding context, the colors, the patterns, and most importantly, its vast library of past experiences to invent a plausible reality to fill the void. It doesn't ask for permission. It simply assumes. It tells you the world is whole because a world with holes would be inefficient and perhaps terrifying. This mechanism is known to science as predictive coding. The brain is not a blank slate waiting to be written upon by sensory data. Instead, it is a prediction engine, constantly generating a model of the world based on what it expects to happen next. This model is our experienced reality, the raw, unfiltered data from our eyes. The photons of light hitting the retina serves primarily as error signals. Their main job is to correct the model when the predictions are wrong. A slight mismatch might create a subtle feeling of unease, the cognitive dissonance of an optical illusion. A major failure of prediction is what we might call shock or surprise. But for the most part, we navigate the world not by seeing what is actually there, but by confirming what our brain has already decided should be there. We are living in a controlled hallucination, calibrated by our senses, just enough to keep us from bumping into walls. Consider the simple act of seeing a shadow dart across the floor. The raw data is a shift in luminance. But your brain doesn't present this to your consciousness as a shifting pattern of dark and light. Instantly, it runs through its predictive catalog. The context is a kitchen. The time is evening. The prediction? It's likely the family cat. And so, that is what you see. You react to the cat, not to the shadow. This system is breathtakingly efficient. It allows us to read messy handwriting, to recognize a friend from a mere glimpse of their silhouette, to catch a ball hurtling through the air by predicting its trajectory. This predictive engine is the cradle of human ingenuity, the foundation of pattern recognition that allows for art, science, and language. It is what allows us to see the lion in the constellation of stars and the face in the marks on the moon. Yet, every cradle can also be a club. This incredible gift of prediction is also our most profound vulnerability. For if we are seeing a version of the world filtered through our expectations, then how much of what we see is truly out there, and how much is simply in here, in the echoing archives of our own past? The same mechanism that lets you recognize a loved one also fuels prejudice, where we see not an individual but a stereotype our brain predicts based on category. The same process that allows us to enjoy a magician's sleight of hand is what allows misinformation to spread through manipulated imagery. We are not seeing reality. We are seeing our brain's best and often laziest guess about reality. We are prisoners of our own assumptions, yet we experience this prison as the boundless world. Is the ultimate illusion the conviction that we are free of illusion? This internal tension between prey and predator, are we the keen-eyed hunter accurately perceiving our environment, or the susceptible prey mistaking a rustling leaf for a stalking beast, has been with us since the dawn of consciousness, but it is now being stress-tested on an unprecedented scale. We have moved from the natural world, the environment our visual system evolved to navigate, into a new digital ecosystem of our own making. We have traded the dappled light of the forest for the relentless glow of the screen. Our eyes, once calibrated to track the graceful arc of a thrown spear or the subtle camouflage of a predator, are now fixated on a flat, pulsating plane of manufactured pixels. Our brain's ancient prediction engine, built to anticipate the patterns of nature, is now drowning in a torrent of artificial visual noise. The images that now flood our retinas are not subject to the laws of physics that shaped our perception. They are designed, optimized, and often weaponized to hijack our predictive coding. A video game's interface, a social media feed endlessly scrolling, a rapid-cut advertisement, all are engineered to provide just enough predictable reward to keep our brains engaged, while introducing just enough novelty to trigger our error correction signals, creating an addictive loop of prediction and reward. The brain's desperate urge to find patterns now finds faces in the front of cars and animals in the clouds. What does it make of the endless parade of filtered, edited, and algorithmically sorted human faces it now consumes for hours each day? The brain that learned to fill in a blind spot is now having its entire visual field filled with commercially sponsored hallucinations. The gentle, forgiving illusions of the natural world, the mirage on hot asphalt, the face in the moon, have been replaced by deliberate high-fidelity deceptions. Deepfakes, sophisticated CGI, and augmented reality filters are not just new technologies. They are direct assaults on our perceptual integrity. They provide error signals so convincing that our brain's model of reality effortlessly incorporates them as truth. The line between the predicted and the actual, always blurry, now threatens to dissolve completely. If our reality is a story the brain tells itself, then who or what is now holding the pen? We find ourselves at a strange crossroads, our most trusted sense leading us into a labyrinth of its own design. The eyes that once guided us to safety and connection now flicker with the ghosts of 1,000 screens, their ancient predictions scrambled by a world they were never meant to see. The very tool that built our reality is now being used to unmake it. So we are left to wonder, not if what we see is real, but which version of the real we have chosen or have been conditioned to see. And as the digital world continues to refine its seductive illusions, a quiet question begins to form in the shadow of all that light. If the eye is so easily convinced by the stories the brain tells, what new stories is it now being taught to believe? We look at our phones for 5, sometimes 8 hours a day. This is not a casual glance, but a deep, sustained immersion. We are pouring our gaze into a flat, virtual world, one bathed in a relentless blue glow that never, ever blinks. It is a world without shadow, without depth, without the gentle flicker of a flame or the subtle shift of light through leaves. It is a constant, demanding presence, and our eyes, ancient, evolved instruments, are meeting a challenge for which they were never designed. This light is fundamentally alien. Unlike the full, rich spectrum of sunlight that has shaped life for eons, the light from our screens is a narrow, intense beam. It tricks the eye, forcing the pupil to remain dilated for longer than nature intended in such bright conditions, allowing in a harsh excess of light. This is why, after hours of scrolling, we feel a dry, gritty sensation, a faint burn. We blink less, our eyes exposed and vulnerable. But the distortion runs deeper than mere physical discomfort. This artificial luminescence plays a sinister tune on our primal biology. It whispers to the pineal gland in the language of high noon, scrambling the signals that tell our bodies it is time to wind down, to rest, to secrete melatonin and fall into the healing arms of sleep. The setting sun outside our window becomes irrelevant. The perpetual noon on our screens holds our circadian rhythm hostage. This new reality has a name: digital eye strain. The symptoms are a modern litany of minor agonies: blurred vision, persistent headaches, a dry and burning sensation, neck and shoulder pain. It is the body's protest, a gentle but insistent alarm bell, ringing from a sense we have always taken for granted. Clinics see it more and more, a quiet epidemic of ocular fatigue. Yet, to see this only as a physical ailment is to miss the profound philosophical shift occurring. The strain is not just on the eye, but on the very way we perceive and consequently feel. Our visual cortex, honed over millions of years, is being fed a diet of information it cannot fully digest. We are asking it to process not the slow, meaningful signals of the natural world, but a frantic, endless stream of artificial symbols, hyper-realistic graphics, and rapid-fire cuts. Consider for a moment the ancestral gaze. Our predecessors spent their days tracing the nuanced expressions on a human face across a fire, reading the intention in a slight frown or a fleeting smile. Their eyes followed the unpredictable dance of wildlife in the trees, the slow march of clouds across the sky, the intricate textures of bark and stone and flowing water. Their world was one of depth, of real distance, of a horizon that pulled the focus into infinity. The eye was a tool for connection, for survival, for awe. It was calibrated for the forest, for the vast savanna, for the subtle cues of a complex social tribe. Now contrast that with the modern gaze. It is funneled into a rectangle of glass. It flickers across thousands of human-made symbols in a single hour: icons, notifications, emoticons, text. It is mesmerized by the infinite scroll of a social media feed, a flat plane of curated lives and fragmented ideas. It is a predator now without prey, a navigator without a horizon, a social creature reading the cold, hard type of a message instead of the warm, living light in another's eyes. The muscles that allow our eyes to converge on a near object and then relax to gaze into the distance grow stiff, locked in a permanent state of close-up tension. The world beyond the screen can become temporarily blurred, a metaphor that perhaps extends beyond the merely optical. And when the gaze is distorted, can the emotion that follows be anything but warped? Vision is our primary sense, the first gatekeeper of experience. It sets the stage upon which our emotional and psychological dramas play out. A world perceived as flat, fast, and demanding may cultivate a consciousness that is similarly shallow, impatient, and anxious. This is particularly, and terrifyingly, evident in the young. For a child, the eyes are the primary gateway for learning about the world. Their visual system is still under construction, its wiring being finalized through experience. What happens when that formative experience is dominated by the two-dimensional blue-lit glow of a tablet? They are learning to see not the world, but a representation of it, not the nuanced emotion on a parent's face, but the exaggerated emotion of a cartoon character. They are learning to focus on the immediate, the bright, the stimulating, at the expense of the subtle, the slow, the real. The cradle of their perception is being shaped by a tool that is also, undeniably, a club. So we find ourselves at a strange crossroads, our most trusted sense caught between the ancient and the algorithmic. We are conducting a massive, unregulated experiment on the human sensorium, trading depth for data, connection for connectivity. The digital eye strain is more than a collection of symptoms. It is the whisper of a dissonance, the physical manifestation of a soul struggling to reconcile its biological heritage with its technological present. We have outsourced our memory to machines, and now we are outsourcing our very perception. The eyes that once scanned the horizon for danger now scan for Wi-Fi signals. Is it any wonder they feel tired? But if this new way of seeing is making us blind to something, what exactly is it that we are no longer able to see? You blink less when you look at a screen. It seems a small thing, an almost imperceptible shift in a routine biological function. Yet this tiny alteration, repeated hour after hour, day after day, is a slow and steady abrasion. It is a new kind of injury, a quiet weariness inflicted upon an ancient sense in the midst of our perfectly normal work. Our eyes are not new. They are old instruments, sculpted over eons by the slow hand of evolution for a world of depth, movement, and fluid light. They were designed to scan the sweeping horizon of a savanna, to track the erratic darting of prey through dappled foliage, to read the subtle shifts in a companion's face from across a flickering fire. They are built for focus that is dynamic, constantly shifting between the intimate detail of a tool in hand and the vast watchful distance for threats. Their natural state is one of gentle, perpetual motion, a dance with a living, breathing world. They were never meant for the static, unwavering stare at a flat plane of light, for the relentless decoding of 1,000 identical symbols on a radiant rectangle. We have asked a sense born of wilderness to live in a cage of our own making, and it is growing tired. The mechanics of this fatigue are both simple and profound. In the relaxed state of a natural gaze, the human eye blinks about 15 times a minute. It is a silent, automatic wiper, a painter of moisture spreading a fresh film of tears to nourish, protect, and optically perfect the surface of the cornea. But when the mind becomes captivated, when consciousness is funneled into the luminous portal of a digital device, this rhythm breaks. The blink rate plummets to a mere 4 or 5 times a minute. The eye, held open and fixed, begins to desiccate. The tear film evaporates, leaving dry spots that feel like grit, that burn with a faint, persistent irritation. The world on the other side of the cornea becomes slightly blurred, and the tiny muscles inside the eye strain to compensate, to force a focus that moisture would have made effortless. Further back, the powerful muscles at the base of the skull, the occipital muscles responsible for the subtle tilts and turns of the head, clench and freeze, holding the entire apparatus rigid. This is the anatomy of digital eye strain. A dry scratch on the surface, a deep ache in the muscle, a throbbing tension in the skull. It is the body's quiet protest, written in the language of pain. And the protest does not end when we finally look away. The consequences of this chronic low-grade assault seep into the fabric of our being. The hours of strained focus bleed into headaches that shadow the rest of the day. The blue, rich light from our screens, a mimic of the midday sun, tricks the ancient clockwork of our brain, suppressing the melatonin that signals rest and repair. It whispers to our pineal gland that it is still day, long after the sun has set, leading to nights of shallow, unsatisfying sleep. We find ourselves lying awake, our minds still buzzing with the phantom light of the screen, our bodies denied the deep darkness they crave. This cycle of fatigue and sleeplessness can become a feedback loop of frustration, and some studies suggest a link to a low-grade, persistent melancholy, a mild depression born not of sadness, but of a fundamental sensory exhaustion. We are draining a well that is never given time to refill. There is a deep irony in how we seek relief. Our ancestors, when their eyes grew weary from the close work of tanning a hide or mending a net, would have found rest by simply looking up. Their respite was in the infinite depth of a cloud-strewn sky, the calming, chaotic dance of flames in a hearth, the complex, soft focus of a human face in conversation. This was not idleness. It was a necessary recalibration. It was the eye returning to its natural parameters of depth, movement, and changing light, a system rebooting itself. Our modern respite, however, is often merely a shift from one demanding screen to another. We finish a day of work on a laptop and seek relaxation by scrolling through a smaller, brighter one. We trade the spreadsheet for the social feed, the word processor for the video game. It is a change of content, but not of form. The eyes remain locked in their prison, the blink rate stays suppressed, the muscles stay taut. We have forgotten what it means to truly let our gaze wander, to let it be passive and receptive rather than active and demanding. In optimizing our productivity, we have engineered the very concept of rest out of existence, and in doing so, we are losing the feel of what it means to be fully, sensorially alive. But perhaps this vulnerability, this newfound frailty of our most trusted sense, is not just a flaw. Perhaps it is a clue. It forces us to acknowledge that we are not abstract minds piloting generic bodies. We are biological creatures, carrying the deep history of our species in every fiber, every reflex, every blink we suppress. Our eyes tell a story of a different world, and their struggle is a testament to how radically we have changed our environment. This weakness reveals our strength, our incredible ability to adapt our world to our will, and our blindness, our failure to remember that our will is still housed in a body that remembers the ancient rhythms of earth and sky. If the strain of the modern world can reveal such profound truths about our evolutionary past, what then of our other perceived limitations? What if a so-called defect, like color blindness, is not an error in the code, but a faded message from a time when seeing differently was not a handicap, but a hidden advantage? We often think of color blindness as a defect, a glitch in the human machine where the vibrant tapestry of the world fades into a muddier, less distinct palette. It is a condition diagnosed, a limitation noted on medical charts, a potential barrier to certain careers. We frame it as a loss, an absence of a faculty the rest of us take for granted. But what if this story is incomplete? What if, woven into the very DNA that codes for this so-called limitation, is a thread of an ancient advantage? The persistence of color blindness in our gene pool is a quiet, enduring mystery. For a trait perceived as a disadvantage to linger for hundreds of thousands of years, it whispers a different tale. It suggests that perhaps, in a different world under a different sun, what we call a weakness was once a keen-eyed strength. The numbers themselves are a puzzle. Roughly 8% of men and 0.5% of women carry the common form of red-green color blindness. This is not a rare, vanishing anomaly. These are significant figures in the grand equation of human genetics, numbers that would be difficult to sustain if the genes responsible were purely detrimental. Natural selection, that relentless editor of our code, is typically unforgiving of such clear-cut errors. It tends to weed out what does not work, sharpening the species toward a functional mean. So why does it allow this particular error to persist generation after generation, a constant, shadowy companion to our full-color vision? Its stubborn prevalence is the first clue that our definition of error might be tragically narrow, a judgment clouded by the comforts and demands of our modern color-coded world. To understand, we must step out of the concrete and glass canyons and into the dappled light of the ancient forest. Imagine the world not as a place of traffic lights and digital displays, but as a vast living mosaic of survival and hunger. This is the realm of the hunter-gatherer, the environment that sculpted our bodies and minds for millennia. Here, the question was not about identifying the correct wire, but about discerning the subtle ripple in the grass that betrayed a predator's crouch, or the faintest shadow of texture that indicated a ripe fruit nestled among emerald leaves. It was a world not of solid, manufactured colors, but of broken patterns and cunning camouflage. In this context, a different way of seeing might have been a precious gift. This is the heart of the hunter-gatherer hypothesis. It proposes that individuals with red-green color blindness possessed a visual talent that their full-color peers lacked. Unencumbered by the dominant signals of red and green, their vision may have been exquisitely tuned to perceive contrasts in texture, to detect slight variations in brightness, and to see through the visual deception of camouflage. Where a deer might melt into a wall of green and brown for a trichromat, its form could be starkly obvious to someone who saw the world in a different contrast. A berry, indistinguishable by its red hue among the foliage, might be revealed by the specific pattern of light and shadow its cluster created. This individual became a specialist in a different kind of sight, a valuable spotter in the communal effort of survival. Their vision was not poorer, it was simply different, attuned to the whispers of the forest rather than its shouts. This paints a picture of evolution not as a straight line toward a single, perfect ideal, but as a strategy of diversification. A tribe, a band of early humans, was a collective organism. Within it, a variety of genetic traits created a portfolio of skills, a buffer against the unpredictable whims of nature. The person who could run the fastest, the one with the sharpest hearing, the one who could track unseen, each increased the group's overall resilience. The colorblind individual, in this light, was not a liability but an asset. They increased the band's collective visual intelligence. This is a form of evolutionary risk management, a biological version of not putting all your eggs in one basket. By maintaining a spectrum of visual perception, the group could perceive more of its world, its collective gaze seeing through more lenses than one. Was the preservation of this gene, then, not a mistake, but a clever ancient bet on the value of a different perspective? Yet, this invites a deeper, more fundamental question about sight itself. Our human vision, in its normal state, is itself a peculiar evolutionary artifact. Most mammals roam the world as dichromats, seeing a palette of blues and yellows but blind to the spectrum of reds and greens that seems so essential to us. So why did we, along with our primate cousins, evolve trichromatic vision? What pressing need drew the color red into our world? This shift is a story written in fruit and flesh. It is thought to be intimately tied to the challenge of finding ripe, nutritious fruit against a backdrop of dense green foliage. The ability to spot a red berry on a green branch is a powerful survival advantage, but it may go deeper, into the realm of social and emotional signaling, the flush of health on a cheek, the blush of anger, the subtle changes in skin tone that communicate feeling and intention. So we are left standing between two ways of seeing, one that embraces a full spectrum and another that finds power in a narrower but perhaps more focused band. One is not inherently better than the other. Each is a tool honed for a specific reality. Color blindness begins to look less like a broken state and more like an alternate configuration, a different tool in the kit. It forces us to question the very idea of normal vision. Is normal merely what is most common, or is it what is most useful? And useful to whom and in what context? The gene for color blindness is a fossil, a genetic memory of a time when seeing the world differently could mean the difference between eating and going hungry, between safety and peril. Perhaps the true limitation, then, is not in the eye of the beholder, but in our own failure of imagination. We live in a world we built for the majority, a world that often forgets the value of the minority view. The story of color blindness is a profound lesson in contextual advantage. It challenges our simplistic notions of advantage and disadvantage, of perfection and flaw. It suggests that our genetic code is not a scroll of errors to be corrected, but a deep and layered history of adaptation and trade-offs. What we label a disability might simply be a once crucial strategy waiting for its environment to return. And so we are left to wonder, if seeing less color can sometimes mean seeing more of the world, what other hidden strengths lie buried within our so-called weaknesses? What truths are we blind to because we are all looking from the same angle, in the same light? If you've ever wondered why human eyes can distinguish red from green, or a ripe yellow banana from the unripe green of its peel, the answer lies not in the realm of art or aesthetics, but in something far more primal: fruit, blood, and the subtle, shifting palette of human emotion. This ability is a profound inheritance, a gift from our ancient ancestors, and its origins are woven into the very fabric of the forests they once called home. Most mammals navigate a world of muted hues. Theirs is a dichromatic reality, built upon two types of light-sensitive cone cells, painting existence in shades of blue and yellow, but blind to the vibrant spectrum in between. They are like patrons in an art gallery, appreciating the sculpture of form and the contrast of light and shadow, but entirely missing the riot of color on the canvases that surround them. The primate lineage, however, including us, took a different path. We evolved a third cone, a biological key that unlocked the world of reds and greens. This trichromatic vision did not emerge so we could admire sunsets or choose coordinating furnishings. It was a survival tool forged in the dense, dappled light of the canopy, The question is, what pressing need in that green world demanded we see red? The forest floor is a study in deception. What appears to be a meal might be poison, and nourishment often hides in plain sight. For a foraging primate, the difference between a tough, unripe, nutrient-poor fruit and a soft, sugar-rich, ripe one is the difference between mere sustenance and thriving. And nature, in its quiet wisdom, signals this difference with a flag of brilliant color. Chlorophyll recedes, and carotenoids and anthocyanins blaze forth in brilliant reds, deep purples, and vibrant oranges. Against a backdrop of endless green, these colors are a beacon. The primate eye, with its newfound sensitivity to this specific chromatic contrast, became a sophisticated food detection system. It could pinpoint a single ripe fig from dozens of feet away, saving precious energy and outcompeting those who still saw the world in a blurrier palette. This was the first chapter of our relationship with color, a practical, hungry search for energy in a green maze. But evolution is a frugal architect, rarely inventing something new when it can repurpose an existing tool for a novel function. The same visual machinery that could spot a fruit-laden branch soon found itself reading a different, far more complex landscape: the human face, the flush of anger, the bloom of embarrassment, the pallor of fear, the subtle rosy glow of attraction or contentment. These are the emotional fruits of our social world. Our skin, uniquely bare among primates, became a canvas for our inner state, and our trichromatic eyes became its keenest interpreters. This was a revolution not in foraging, but in feeling. The ability to discern a slight reddening of a cheek or a tightening of pallor granted us a window into the minds of others. It became the foundation of empathy, a biological bedrock for the intricate dance of social connection. We could sense a companion's rage before a word was shouted, or their shame before they hid their eyes. This silent language of color allowed for deeper bonds, more complex alliances, and a more nuanced and stable social structure. Yet this powerful tool carried a double edge. The same sensitivity that fosters empathy also equips us for judgment. We read the flushed face of a speaker and decide if they are passionate or unhinged. We see the pallor of a colleague and gauge their fear or weakness. We unconsciously assess health and vitality in the subtle, rosy undertones of skin, making snap judgments about attractiveness and vigor. Our vision, honed to detect the ripest fruit, now sorts the people around us, often without our conscious consent. It is the basis for both profound connection and swift, often unfair, social assessment. The cradle of empathy is also, unavoidably, a club of perception. So, if our eyes evolved to find fruit and then were co-opted to read emotion, what is the ultimate, most raw expression of feeling they are asked to decipher? What happens when the body's signal is not a subtle flush, but a flood? The answer may lie in a phenomenon that is uniquely, powerfully human: the act of crying. When emotion overflows its internal banks, it doesn't just color our cheeks, it wells up in our eyes, clouding our vision with saline tears. It is a total surrender of the organ of perception to the force of feeling. The eyes that spent eons learning to scrutinize the external world for the subtlest signs are momentarily blinded by an internal truth they can no longer contain. They become not a window to look out of, but a portal for what must escape from within. So we are left to wonder, in the grand, pragmatic theater of evolution, where every trait is supposed to confer a clear advantage, what possible benefit could there be in this? What survival value is there in a signal that blurs your own sight, that reveals your vulnerability to friend and foe alike? The red brimming eyes of a person in grief or overwhelming joy seem to defy the very logic of natural selection. They are a paradox, a moment of supreme weakness that often elicits the strongest offers of help and comfort from others. It is the body's ultimate, undeniable confession, a truth told not in the subtle hue of skin, but in the honest, helpless overflow of tears. Perhaps, then, the weeping eye is not a flaw in our design, but its most profound refinement. If our vision for color began by seeking sustenance in the forest, Could it be that its highest purpose is to recognize the need for sustenance in another human soul? The eye that learned to find the ripest fruit might finally be learning to ask for kindness. But why would evolution choose such a vulnerable, exposing display? What is the hidden strength in this apparent weakness that compelled nature to let our feelings spill over for all the world to see? The air shudders in a ragged gasp. A hot pressure builds behind the eyes, a dam straining against a tide of feeling. Then, the breach. A silent tear traces a path down a cheek, followed by others, a saline river carrying the unspeakable weight of a broken heart, a profound loss, a helpless frustration. And in its wake, it leaves an unmistakable signature, the red-rimmed, glassy, and slightly swollen eyes of someone who has wept. It seems, on its surface, like a spectacular design flaw. In a world that often rewards strength and conceals weakness, why would evolution choose to paint such a vivid, undeniable banner of our vulnerability right in the center of our face? Why broadcast our internal chaos with such unflinching physiological honesty? We are the only species on this planet that sheds tears for reasons beyond the physical. An elephant may mourn its dead, a dog may whine in loneliness, but their grief, however deep, remains a dry affair. Our tears of emotion are a biological signature unique to Homo sapiens, a strange and poignant alchemy where a feeling, an abstract, intangible storm in the mind, manifests as a tangible, chemical event in the body. This is not the simple ocular plumbing that flushes away an irritating speck of dust. This is a different system entirely, a secret language written in salt water and hormones, activated not by a foreign body, but by a wounded spirit. Science, in its methodical way, has begun to decipher the code of this cryptic signal. Emotional tears are not mere salt water. They are a complex cocktail of stress hormones like adrenocorticotropin, ACTH, and leucine and enkephalin, a natural painkiller. They contain prolactin, a hormone associated with caregiving and bonding. When we cry, we are quite literally washing our sorrows away, purging our system of the very chemicals that flood our bodies during distress. It is a built-in physiological pressure valve, a private internal balm. But if the function were merely private, evolution might have devised a less conspicuous method, an internal sigh, a hidden gland. The very public nature of the act, the red eyes and glistening cheeks, suggests another, far more social purpose. Imagine our ancient ancestors, living in small, interdependent bands on the vast and unforgiving savanna. Survival was a collective endeavor. A solitary human was a dead human. In such a world, communication was everything. But how does one convey a pain that has no physical source? How does one articulate the crushing weight of grief, the paralyzing fog of despair, or the profound ache of betrayal with mere grunts and gestures? Language was still in its infancy, too clumsy and slow for the immediacy of such raw feeling. Evolution's answer was devastatingly simple and profoundly effective. The emotional tear. It is a signal that bypasses the need for complex vocabulary. It is an unambiguous white flag. The red, watery eyes are a biological billboard that reads, in a universal language understood by all, I am hurting. I am overwhelmed. I need help. This signal is incredibly difficult to ignore. We are hardwired to respond to the human face, and the signs of weeping trigger an almost instinctual empathy in others. The reddened eyes soften the hardest countenance, disarming potential aggression and inviting compassion instead of conflict. It is the ultimate gesture of surrender and trust, laying bare one's vulnerability in the hope of receiving care, not a blow. In this light, the red eyes are not a flaw, but a feature, a sophisticated social tool that fosters connection, strengthens bonds, and facilitates reconciliation. It is the glue that holds communities together through shared feeling. It allows us to see, instantly and unmistakably, the inner state of another, building a bridge of understanding over the chasm of individual experience. This stands in stark contrast to the rest of the animal kingdom, where the primary rule is often to conceal weakness. A limping animal becomes prey. A distressed cry can attract a predator. The instinct is to mask pain, to put on a strong face, to hide any sign that might mark one as vulnerable. Humanity, paradoxically, evolved a different strategy. We evolved to advertise our vulnerability. We developed this exquisite leaky system that broadcasts our need for others. In doing so, we traded the solitary strength of the predator for the interconnected strength of the tribe. Our weakness, openly displayed, became our greatest strength. It is the foundation upon which we built not just survival, but society itself, with all its intricate networks of empathy, altruism, and mutual care. The red eyes of tears are not a badge of shame. They are the badge of our humanity, the price of admission into the profound and fragile web of human connection. And so, in that moment of shared vulnerability, when one person's red-rimmed eyes meet the gaze of another, something fundamental occurs, a silent transaction of understanding. The observer does not just see swollen tissue and dilated blood vessels. They see a reflection of a universal human capacity for suffering. They are granted a fleeting, powerful window into another soul's storm. This act of witnessing, of truly seeing another's pain, is perhaps the most critical catalyst for the emotion we call compassion. It is the spark that ignites the impulse to reach out, to comfort, to share the burden. But this reliance on sight, on the visual cue of suffering, leads us down a deeper, more unsettling path. If our morality is so deeply tied to what we can see, to the immediate visceral evidence of another's pain written on their face and in their eyes, what becomes of the suffering that remains invisible, the internal agony that does not manifest in tears, the private despair that hides behind a calm smile, the systemic pain that occurs out of our line of sight? Does it become, in some way, less real to us? If the red eyes are the trigger for our compassion, is our innate morality rendered blind to all that does not make us cry? We feel a pang, a visceral twist in the gut when we see a stranger wince in pain. A flicker of shared agony passes through us at the sight of tear-filled eyes or a face contorted by grief. There is no introduction, no shared history, no language required. It is an immediate unspoken conversation between two nervous systems. This instinctive response, this ability to truly see the suffering of another, feels like the very bedrock of our humanity. But is it a simple, hardwired biological reflex, a survival tool etched into our DNA? Or is it, in fact, the first and most fundamental lesson in morality, the raw material from which all ethics are forged? Imagine a scene etched in the deep amber of prehistory. A small band of early humans moves through a landscape both bountiful and brutal. The success of this group, its very survival, hinges on an invisible web of mutual understanding. A hunter returns to camp, not with a triumphant haul, but limping, his body telling a silent story of a close encounter with sharp tusks or treacherous terrain. The response of the others is not calculated. It is instantaneous. Hands reach out to steady him. A share of scarce food is moved toward him. A low, soothing murmur passes between them. In this moment, the ability to read the silent language of pain, the slight hitch in the breath, the guarded posture, the shadow in the eyes, was not a sentimental luxury. It was a critical social technology. The individual who could not see, or worse, who willfully ignored these signals, was a liability. They weakened the cohesive fabric that protected everyone from the existential threats of hunger, predators, and rival groups. Their social exclusion was not merely a punishment, it was a biological imperative, a quiet editing of the gene pool to favor those wired for connection and care. The survival of the fittest in the end may have depended profoundly on the survival of the kindest. This ancient, silent dialogue of care is not some mystical force. It has a precise address within the architecture of our brains. Modern neuroscience maps this profound connection onto the wet, gray matter of our skulls, revealing a story as elegant as any philosophical treatise. When our eyes capture the image of a suffering face, That visual data is first processed in a region known as the superior temporal sulcus, a specialized area adept at reading the complex social cues of biological motion, gaze, and expression. But the signal does not stop there. It rockets along a neural highway, a rich cable of fibers directly into the heart of our social and emotional brain, the medial prefrontal cortex. This region is the seat of moral reasoning, of understanding the self and the other. The raw visual data, a furrowed brow, a downturned mouth, is thus transformed. It is imbued with meaning, with emotional resonance. It becomes suffering, not just a configuration of features. This entire network, this lightning-fast cascade of electricity and chemistry, fires with remarkable consistency across cultures and continents. It activates even in infants long before language provides labels for emotions. It is a universal pre-linguistic grammar of empathy, written into the very core of our being. We know another's pain because our brains are built to translate their silent visual story into our own emotional language. This neural narrative presents a fascinating contrast to centuries of moral philosophy. So much of our discourse on ethics is built upon grand abstract principles, Kant's categorical imperative, utilitarianism's greatest good. We envision morality as a towering edifice of logic, constructed through reasoned debate and intellectual rigor. Yet, the engine of compassion seems to ignite not in the rarefied air of abstract thought, but in the humble, immediate soil of an image. A single trembling lip, the weary slump of a pair of shoulders, the desperate plea held in a stranger's gaze. Vision is the first gate, the most direct portal through which we connect with the inner world of another being. It bypasses the convoluted pathways of language and explanation, delivering its message of need directly and unforgettably to the heart. We do not need a philosophical argument to tell us that suffering is wrong. We need only to see it. Our morality, then, is not a castle built entirely in the sky of reason. Its foundations are sunk deep into the earth of perception, held firm by the simple, profound act of seeing. But if the eyes are such a potent conduit for truth, such a reliable trigger for our innate compassion, then a darker, more unsettling question begins to form in the shadows. This very gateway of connection, so essential for building trust and community, can also be the most effective tool for its betrayal. For what is to stop an actor from learning this silent language, from mimicking its grammar to produce a forgery? The same eyes that well with authentic tears can be made to simulate them. The same face that contorts in genuine agony can be twisted into a mask of deceit. The neural machinery that evolved to bind us together in mutual care contains, within its very design, a catastrophic vulnerability. If we are so exquisitely tuned to believe what we see, then the greatest weapon against us would be a convincing lie written on the face of another. And so, we are forced to wonder, did evolution, in its relentless drive to foster cooperation and compassion, also inadvertently craft the perfect instrument for manipulation? Never trust the eyes. The phrase sounds like a line from a poet's notebook, a warning born of heartbreak and cynicism. But what if its roots are far older and more primal than literature? What if this cautionary tale is written not in ink, but in our very DNA? We look into another's eyes searching for a window to their soul, for a flicker of truth in a world of ambiguity. Yet, could it be that this very organ of sincerity is also evolution's most masterful tool for deception? The natural world is a grand theater of illusions, and the eye is a central prop in its endless performances. The peacock butterfly, with its stunning wing patterns that mimic the unblinking gaze of a large predator, uses false eyes to startle and deter hungry birds. In the dappled light of a forest floor, a moth remains perfectly still, its hidden eye spots making it appear not like a meal, but like the face of an owl. Beneath the water's surface, the sand dab flattens itself against the seabed, its two eyes migrating to one side of its head in a bizarre asymmetrical configuration, a brilliant adaptation for both hiding and watching. Even among our closer relatives, the primates, the art of the deceptive glance is a refined social skill, A young chimp might stare off into the distance with a feigned look of alarm, distracting its troop from a hidden cache of fruit, only to circle back and claim the prize alone. In these moments, the eye is not a beacon of inner state, but a calculated signal, a mask worn for survival's sake. It is a club as much as it is a cradle. Humans, for all our complex language and culture, are not exempt from this biological heritage. We are born into this legacy of looking. From a startlingly young age, we learn that a direct gaze can command attention, averted eyes can signal submission, and a well-timed, wide-eyed expression can convey innocence or surprise. We consciously practice these looks in mirrors, refining the subtle musculature around our orbits to project confidence, empathy, or interest. The common intuition is that a liar will avoid eye contact, shifty and guilty. Yet, the most proficient deceivers among us know this cliché and weaponize it against us. They understand that to convince, one must not hide, but overwhelm. They practice maintaining a steady, unwavering gaze, a performance of sincerity so intense it becomes more believable than the truth itself. They learn to fake the subtle crinkling around the eyes, the Duchenne marker of a genuine smile, that we unconsciously read as the ultimate sign of authentic joy. They offer the very connection we crave, but it is a mirage. This creates a profound and unsettling paradox. The same evolutionary pressures that gifted us with an exquisite sensitivity to the nuances in another's gaze, the slight dilation of a pupil indicating interest, the micro-expression of fear flashing across the iris, also gifted some the ability to forge those very signals. We evolved to read the story in the eyes, and in turn, we evolved to write fiction within them. The tool for deep connection and empathy is thus perverted into an instrument of social manipulation. It is an arms race of perception, a silent battle fought in glances across dinner tables and negotiation rooms. We are both the audience and the actor in this eternal play, desperately trying to discern the real from the performed, knowing that our own tools of perception are the very things being used against us. So if the human eye is such an imperfect, malleable, and deceivable instrument, if it can be so easily turned from a window into a wall, how did we ever manage to trust it enough to build the intricate societies we have? How did a species, seemingly so vulnerable to the lies held in a glance, not only survive, but thrive? The answer may lie not in the perfection of our vision, but in the profound imperfection we learn to navigate together. What is the true cost of seeing when the very act of looking invites both truth and deception to dance behind the same lens? We are a species of contradictions. We are not the fastest nor the strongest. We lack the armor of a tortoise, the acute hearing of a deer, and the crushing power of a great cat. And our eyes are, by many objective measures, profoundly average. We cannot see the world with the razor-sharp, kilometer-piercing clarity of an eagle. We do not possess the expansive, nearly panoramic view of a rabbit, forever on guard. We are blind in the deep darkness where a cat moves with silent, confident grace. So why is it that this pair of mediocre optical instruments, this biological compromise, not only ensured our survival but became a cornerstone of our dominion over the planet? The answer lies not in the sheer power of the lens, but in the profound complexity of the processor behind it, and the social world it was built to see. Imagine standing on a prehistoric savanna. The sun is high, the grass whispers in the wind. Your ears catch a sound, a rustle. An antelope might freeze, its wide-set eyes scanning a broad field for the slightest hint of a stalking shape. A bird of prey might circle high above, its gaze locked on a tiny scurrying dot far below. But you, the human, your eyes are set close together on the front of your face, limiting your peripheral vision, creating a vulnerability. This seems like a weakness, a trade-off that demands constant vigilance. Yet, this very configuration is our first evolutionary masterstroke. It grants us stereoscopic vision, the ability to perceive depth with exquisite precision. That rustling in the grass isn't just a sound, it's a point in space. Your brain, using the slight disparity between the images from your left and right eye, calculates the exact distance to the source. Is it a predator 30 paces away, or just the wind teasing a bush 2 paces to the left? This depth perception is the difference between a successful throw, a well-aimed thrust of a spear, and a futile, energy-wasting miss. It turned our hands from mere grasping tools into lethal, projectile-launching extensions of our will. But survival is more than hunting. It is also about connection. Our eyes did not evolve merely to locate prey and predator, but to read the most complex and subtle map ever drawn, the human face. In the slight narrowing of eyes, we detect suspicion. In the subtle upturn of lips, we see the faintest promise of a smile, a signal of alliance. The widening of eyes can signal shared alarm or shared wonder. We became masters of nuance, our visual cortex dedicating astonishing real estate to decoding the silent language of micro-expressions that flicker across the faces of our tribe. This ability to see emotion, to build trust, to coordinate without a sound, was a force multiplier far greater than any claw or fang. A lion is strong alone, but a human, connected to 10 others by a shared glance, a nod of understanding, a look of warning, becomes part of something immensely powerful. Our eyes became the primary conduit for empathy and social cohesion, allowing for the kind of large-scale cooperation that would eventually build cities and launch satellites. We were not looking out at the world as solitary individuals, we were looking at each other, and in that shared gaze, we found our strength. This is the grand paradox of human vision. It is a jack-of-all-trades system in a world of specialists. The eagle's eye is a superb telescope, but it is a poor tool for reading the emotional state of another eagle mid-flight. The cat's eye is a magnificent night vision device, but it cannot discern the rich tapestry of colors that might indicate a fruit is ripe or a patch of earth is fertile. Our eyes, however, are the ultimate generalists. They can track a thrown rock in a bright blue sky, discern the faintest blush on a berry, read the intricate symbolism of written text, and catch the almost imperceptible furrow of a brow that signals dissent in a council meeting. This flexibility, this cognitive bandwidth, is our true advantage. Our survival was not guaranteed by being the best at any one visual task, but by being good enough at all of them, and brilliant at integrating that visual information with a complex social brain. So we thrived, not despite our optical limitations, but because of the unique way our brain transformed light into meaning. Our eyes were never just biological cameras. They were the first social network, the original interpreters of a world filled with both tangible threats and intangible bonds. They are the cradle of our empathy and the club of our collective action. But this intricate system, so finely tuned by millennia of evolution, now faces a new, quiet revolution. For most of our history, sharp vision was non-negotiable. A blurry world was a dangerous world, a world where you couldn't spot the predator, aim the weapon, or see the affirming nod of your companion. Yet, walk through any modern city today, and you will see a spectacle that would have been unimaginable to our ancestors. A significant portion of the species moving through life with polished crystals or engineered polymers perched on their noses, correcting for flaws that would have once been a death sentence. Myopia, astigmatism, hyperopia. These weaknesses are now commonplace, even as our species continues to advance. How can this be? If natural selection is a relentless editor, why has it not corrected these pervasive errors in our most vital sensory equipment? The story takes another fascinating turn. The very social world that our eyes help to create may have, in turn, begun to reshape the eyes themselves. Some theories suggest that the increase in nearsightedness is linked to a modern environment of close-up work, reading, scrolling, focusing on screens, a far cry from the long-distance horizon gazing of the plains. But the deeper, more profound answer might be even more fundamental. Perhaps our eyes were never meant to be perfect in isolation. Their ultimate evolutionary purpose was to connect us. And in that we found a solution more powerful than any biological adaptation. We evolved the capacity to see for one another. The individual weakness of one pair of eyes became irrelevant when the knowledge to correct it could be shared, taught, and engineered across the collective. The optometrist is as much a product of our evolution as the stereoscopic eye. We are a species that outsources its own perfection. So, if our survival was secured not by the perfection of the individual, but by the interconnection of the group, then what does it mean that we now so easily correct the physical flaws that once bound us to a brutal natural law? We mastered the world by learning to see each other's souls. Did we then earn the right to finally fix our own faulty lenses? Our ancestors could spot a predator moving in the tall grass 100 meters away, a faint silhouette against the shifting light of the savannah. Their survival, and the survival of those around them, depended on that sharp, distant focus. Today, we squint to read a text message on a screen held just a few inches from our faces, the world beyond a blur of indistinguishable shapes. In the relative blink of an evolutionary eye, the very tool that once scanned the horizon for opportunity and threat has turned inward, shortening its gaze, retreating from the vastness of the world to the confines of a glowing rectangle. What profound shift in our existence has caused this rapid, widespread rewiring of human sight? The statistics read like a silent epidemic. Refractive errors, myopia, astigmatism, hyperopia, are exploding across the modern world, particularly among the young. In some urban centers of East Asia, the rate of myopia, or nearsightedness, in young adults has soared past 90%. This is not a minor inconvenience. It is a mass alteration of a fundamental human sense. Yet the archaeological and anthropological record suggests our forebears were largely spared. Their eyes, honed over millennia, were calibrated for the distances of a natural world. This disparity between then and now is not a mystery of genetics alone, but a direct and powerful reflection of the new world we have built for ourselves. We are living in an unplanned experiment, and the results are written in the weakening vision of a generation. The knowledge we now possess points a clear, if unsettling, finger. The eye is not a static camera. It is a dynamic, living organ that grows and shapes itself in response to its environment. In childhood, when the eye is still developing, it requires a certain chemical signal to tell it to stop growing. That signal is dopamine, released in the retina by exposure to bright, natural sunlight. For the developing eye of a child, hours spent outdoors are not merely recreation, they are essential maintenance. They are the biological instruction that keeps the eyeball's shape in balance, ensuring that light focuses perfectly on the retina. Our modern life, however, is lived increasingly indoors, under the dim, artificial glow of ceilings and screens. We have swapped the sun-drenched expanse of the outdoors for the controlled climate of the classroom, the office, and the living room. This lack of luminous intensity is the first crack in the foundation. Compounding this deficit of light is the nature of the work we now ask our eyes to perform. For millennia, the human gaze was a restless thing. It would dart from a close-up task like tool-making to the middle distance, to the far horizon, constantly flexing its focusing muscle, the crystalline lens. This varied workout kept the system supple and strong. Now, we demand a relentless, unwavering focus on the near field. The page of a book, the spreadsheet on a monitor, the endless scroll of a smartphone. All these objects live in a cramped visual space, just a foot or two from our faces. To maintain this focus, the eye's muscle must contract, and the brain, in a feedback loop we are only beginning to understand, seems to signal the eyeball itself to elongate ever so slightly. This elongation is the very architecture of myopia. Light now focuses in front of the retina, making distant objects appear blurry. We have, quite literally, sculpted our own eyeballs to better suit the confines of our artificial caves. Genetics loads the gun, but environment pulls the trigger. This transformation is more than a medical condition. It is a profound philosophical shift. The human eye evolved as a flexible instrument of survival in a world of depth, movement, and variable light. It was designed for the dappled shade of a forest, the shimmer of heat on a plain, the swift movement of prey or predator. It was a tool for navigation, for connection, for reading the subtle cues of a complex social world. Now we have bent this instrument to a new purpose. We have traded the horizon for the home screen, the unpredictable movement of nature for the predictable flicker of pixels. Our visual universe has been flattened and shrunk, our eyes becoming specialized for a narrow band of artificial reality. We took a tool shaped by the wind and the weather and placed it under a glass bell jar. Is it any wonder it has begun to change? And as our visual acuity diminishes, are we losing more than just clarity? Are we forfeiting an entire dimension of emotion and understanding? The eyes were our first and most vital social tool. Long before language, we read intention in a glance, trust in a steady gaze, threat in a narrowed eye. We evolved an exquisite sensitivity to the human face, to the micro-expressions that flicker across it, telling stories words never could. This ability to connect, to empathize, to truly see another person, is a cornerstone of our humanity. But what happens when a generation grows up seeing the world through a persistent, slight blur? When the fine details of a face at a conversational distance are softened and lost? When we increasingly interact through digital avatars and filtered images rather than face-to-face? The screen mediates not just what we see, but how we see each other. If our window onto the world of human connection is gradually frosting over, what does that mean for the quality of the connection itself? We have focused so intently on the mechanics of vision, the elongation of the axis, the correction with lenses, that we risk missing the larger, more subtle transformation. This is not just about the inability to see a street sign clearly. It is about a fundamental recalibration of our primary interface with reality. We are slowly, inexorably, trading a vision designed for depth and space for one optimized for the flat, the close, the artificial. We are choosing a world of our own making over the one that made us. And in doing so, we must wonder, if the eye is the window to the soul, what becomes of the soul when the window begins to close? But perhaps the most intriguing question lies not in what we are losing, but in what we are adapting to become. For this shift in vision is merely the physical echo of a deeper cognitive change. If we can no longer see the far distance, do we stop thinking about it? If our world is composed of curated close-up information, does our understanding of reality itself become nearsighted? The journey of the eye, from horizon scanner to screen reader, is complete. But a new journey is just beginning. What happens when vision is no longer just about seeing, but about understanding? You can remember a person's name, their job title, even the sound of their laugh, but their face remains a shifting, indistinct landscape. You see a familiar smile, a pair of eyes that you know should spark a cascade of recognition, but the connection fails to ignite. This is not a failure of memory, a social faux pas, or a sign of indifference. It is a profound and peculiar fracture in perception itself, a condition where the most fundamental tool of human connection, the face, becomes an indecipherable mask. This is prosopagnosia, or face blindness. A person with this condition can see perfectly well. They can describe the geometry of a nose, the curve of a lip, the arch of an eyebrow with clinical precision. Yet the unique constellation of features that forms an identity, that whispers mother, lover, or friend, remains silent. The world becomes a sea of strangers, where even one's own reflection can sometimes seem oddly unfamiliar. Renowned neurologist Oliver Sacks wrote of his own prosopagnosia, describing how he would sometimes apologize to a large, bearded man for being in his way, only to realize he was addressing a mirror. Actor Brad Pitt has spoken of the social isolation it brings, the constant fear of offending others by not acknowledging them, of being perceived as aloof or arrogant. Their experiences reveal a chasm between seeing and knowing, a gap in our reality that most of us never have to contemplate. The existence of such a specific deficit points to a remarkable truth about our brains. We are not general-purpose computers processing visual data. We are specialists, honed by evolution. Nestled within the temporal lobe of the human brain is a small, specialized region known as the fusiform face area. This is the neural workshop dedicated solely to the intricate art of facial recognition. It is a biological testament to the supreme importance of the human face in our social world. When this area is damaged, by a stroke, a head injury, or sometimes from birth, the ability to recognize faces can vanish, while the ability to recognize objects, places, and even other aspects of a person, their gait, their voice, often remains perfectly intact. It is as if a single crucial circuit in the vast machinery of social interaction has been severed, leaving the rest of the machine whirring pointlessly. What does it mean that our social cohesion is so fragile, so dependent on this one small piece of neural real estate? Imagine an early human standing on a sun-drenched savanna. The rustle in the grass could be a friend or a predator. The figure approaching from a distance could be a tribesman returning from a hunt or a rival scout. In that moment, the instantaneous, unconscious recognition of a face was not a social nicety. It was a matter of life and death. To mistake a friend for a foe, or worse, a foe for a friend, could be catastrophic. Our brains evolved under this relentless pressure to categorize, to connect, to belong. For the prosopagnostics in the modern world, the stakes are different, but the underlying terror of social disconnection remains. The conference room, the party, the family dinner. These become the new savanna, fraught with potential missteps. The inability to recognize a colleague can feel like a betrayal. The failure to see a loved one in a crowd can induce a profound loneliness. This condition holds up a mirror to our own social reality, reflecting back the immense, invisible weight we place on the simple act of seeing a face. If our social world is built upon this fragile visual thread, how many other unseen threads hold us together? And what happens when they too are cut? We think of our eyes as our own, as private windows onto the world. We use them to navigate, to learn, to appreciate beauty. But the experience of prosopagnosia suggests a more profound and unsettling truth. Our vision, at its most sophisticated level, is a social instrument. It is a tool forged not for solitary observation, but for connection. The eyes are not just for seeing. They are for recognizing, for bonding, for building the intricate web of relationships that defines a human life. They are less a personal window and more a communal bridge. This forces a question that reverberates far beyond a single neurological condition. If our most basic sense is so deeply wired for the other, where does the self-end in society begin? Is the image we see in the mirror truly our own, or is it a reflection crafted for the eyes of others? And if the eye is indeed a tool of such profound social power, a bridge between isolated consciousnesses, then how did this fragile, watery organ, this vulnerable biological lens, so easily damaged by dust and time, transcend its physical form to become one of humanity's most potent and universal symbols? How did it come to represent the all-seeing gaze of a god, the terrifying eye of providence on a pyramid, or the mesmerizing window to a soul we believe can look back at us? How does something so weak command such power?